Hey, this is Juan Tutors. Today we are going over the full January 2025 Algebra 1 Regents. We are going to go through the whole test, and this video is vertical so that you could see more of the work. One of the things that you'll notice about this video versus other people's videos also, my videos always end up being longer than other people's videos. And why is that? It's because I'm going to show you how to do every single problem and get a perfect grade on the test. And I know that a lot of you are begging, wait, Juan, how do I get 65. How do I pass the Algebra 1 Regents? How do I get a 65 on the Algebra 1 Regents? How do I get, I'm already passing. How do I get an 80 on the Algebra 1 Regents? How do I get a 90? How do I get 100 on the Algebra 1 Regents? And my goal is to get you the best grade possible. And I think one of the things you'll notice today is that if your goal is to pass only, yes, your goal might be to pass. But if you actually set that as your target, then you might actually be taking on strategies that actually are worse for you, because there actually is no strategy that gets you closer to passing that also isn't beneficial all the way across to get you 100. And in fact, if you start using strategies that are not helpful, you might find that you're actually not passing. So one of the things it says here, indicate the necessary steps, including appropriate formula substitutions, diagrams, and graphs, and charts, etc. And of course, you have to do that on part 2, 3, and 4, but also on the part 1. And you might be saying, Juan, do I have to show work on the part 1s to get full credit? We don't even look at your work on the part 1s to grade your test. In fact, we just take the sheet that you filled out, the bubble sheet, and we literally scan it through the machine. We don't even look at it besides your name. And in fact, even your name, we check if your name matches the name that's printed. That's it. We purposely do it that way so that we don't have to use wishy-washy methods to make sure that you got the answer right. We literally scan it, we don't touch it. So why are you going to show work on the part 1s? I'm going to show you why when we get to the problems. The other piece, a piece that's not so relevant for you guys because it's more relevant for the geometry regions, but this last statement, note that diagrams are not necessarily drawn to scale. I actually have my students cross out the words not necessarily and write the words almost definitely. Why? Because it turns out that if you actually go the other way and don't assume that diagrams are to scale, which is what a lot of teachers say, and you actually go the other way and say, I'm gonna assume that the diagrams are drawn to scale unless I happen to know for a fact that it's not, you actually are way more likely to get the question right. So it's diagrams are not necessarily drawn to scale does not mean that they're not drawn to scale. It means that they don't have to be. And in fact, in most cases, the Regents people, it might feel like they're just evil incarnate and they're trying to confuse you, but actually they're just not trying to confuse you at all. They're actually trying to write an honest test that tests your abilities. So because of that, if they actually make every diagram not drawn to scale, it would cause confusion. Therefore, they actually make almost every diagram drawn to scale. That said, that's more relevant for geometry when you get there, which if you're taking the Regents, you're literally going to be there in maybe a month or two. So that's good advice for you to have now. That said, we are going to jump into number 1 on the January 2025 Algebra 1 Regents. When factored, the expression x cubed minus 36x is equivalent to x plus 6, x minus 6, or x plus 18, x minus 18, or x times x plus 6, x minus 6, or x times x plus 18 times x minus 18. This is I love that they started off with this problem because I get to immediately tell you that there is a way to do this problem without actually doing the algebra. Now, I need to make an exchange with you. I will agree to show you really good strategies on how to get questions right, even if you don't know how to do the problem. But in exchange, you got to actually watch me do the problem the long way. And the reason I need you to watch me to do the problem the long way, meaning not the long way, meaning the actual standard using math way, is that if you notice, if I actually just cross out all of these answers, just cross them all out, this is a part 2 question. In fact, that's the real point that I'm trying to make. You can't really do phenomenally on this test and then just show work on the part 2s, 3s, and 4s because the part 2s, 3s, and 4s are literally part 1 questions. Okay, so that's the thing. You actually have to show work on the part 1s to get full credit. And in fact, if you notice, if you look at what my test looks like, my test, and this is just me doing work for just myself, the test has tons tons of work written into it. That's actually, and it's okay that it's blurry because you don't actually have to be able to see it. The whole point that I need you to see is that am doing work, and I'm doing work not because to show you that, but this is like literally me doing work without anybody else seeing my work. I could literally do all of these problems at this point without having done them to begin with, but I need to be sure. And the only way for me to be sure is if I show all the work. And that's the same thing for you. So I'm going to show you how to get this question right without knowing how to do the problem. I wish you did know how to do the problem, but let's check out this strategy. Okay. So I'm gonna also get a bigger screen, view detached LCD. Okay, so you can see a nice big screen there. Okay. Actually, let me scroll here. Let me make the screen a little bit bigger again. There we go. Okay, so what I'm gonna do, I'm gonna go here. I'm gonna type in x cubed minus 36x. Now, every single time I do this Regents, I pick a random choice that I'm just going to make that my favorite choice to plug in just to show you testing. Why am I going to do that? Because I don't want to always test the correct answer, nor do I purposely want to test the incorrect answer. My random number generator says that I'm going to choose the number choice 2 to always plug in just as a test value for me to show you how I plug in a test value. So choice 2 says x plus 18x minus 18. Suppose as a student, I suspect that the answer is x plus 18x minus 18. Then as y2, I'm going to plug in parentheses, x plus 18, close and open parentheses, x minus 18, close parentheses. And then what I'm going to do is I'm going to go to the table of values. Table is in blue, so I press the blue second button. Press table. And I can actually scroll up and down, and I see that y1 and y2 are not the same function. Y1 and Y2 are not the same function. And I know they're not the same function because they don't have the same values. For example, at x equals 12, Y1, which is the original function, is 1,296, and Y2 is negative 180. Not the same function. Therefore, choice 2 is not the correct answer. Okay? And that's how I can get the answer with 100% certainty. So this method gives you the answer with 100% certainty. Now, am I going to do it that way with 100% certainty? Well, I'm not, because I'm not going to sit there and waste your time and show you me plugging in choice 1, 3, and 4 till I finally get the answer, right? Because that's your job. But you now have a way to do this problem with 100% certainty. Plug into y equals. That will give you 100% of the answer, which turns this into a guaranteed and perfect grade for this problem. Why is that relevant? Do you know how many students get this question wrong? It should be 0. It should be 0 students get this question wrong, because I just showed you a foolproof way of getting this question right. But a lot of students get it wrong because they don't bother plugging it into the calculator. So now because you watch this video, you get to get this answer right with 100% certainty. Now, because this could be a part 2 question, let's actually do this problem the way algebra says. And by the way, there is another reason why I know that choice 4 is incorrect. Choice 4 is incorrect because although it's a cubic, when you multiply the constants, 18 times negative 18 is not negative 36. 18 times negative 18, I believe, is 324. And this has a negative 36. So you get a negative 324x instead of a negative 36x. That's incorrect. So now I have a 50% chance of getting it right without even plugging in. But one of these two answers, now I don't like this one because this one is quadratic and this one is a cubic. Now I actually already know the answer without having done the algebra yet another way. So yet another way to demonstrate that there's actually multiple ways of eliminating the incorrect answers. That's a big lesson. So let's actually do the algebra. So x cubed minus 36x. So both of these terms have an x, and that's equal. So I can factor out the x, and the remaining factor pairs, x times x squared is x cubed, and minus 36 times x is 36x. So the factor pair is 36. Okay? Now, this is not factored completely. This would be an answer choice on Algebra 2 Regents, by the way. So they're looking for you to see, in the Algebra 2 at least, whether you are typing answers complete, whether you are factoring completely. Not in Algebra 1, though. Algebra 1, they usually check if you're just factoring completely and just getting the right answer. Meaning that the answers are almost 100% guaranteed to have only one that actually matches the original function. So what about this one, x squared minus 36? So this is a difference of two squares, DOTS, difference of two squares. Or DOPS, and I heard this one from another student. DOPS is a difference of perfect squares. Either way, same wording, same thing. So what's a difference of two squares mean? So if you have p plus q times p minus q, if you do this by the box method or FOIL, I'm a fan of the box method because the box method corresponds to a method called each with each. I'm not a fan of FOIL anymore because it only works by binomial times binomial. Each with each works all the time. Box method works all the time. So if you multiply p times p, it's p squared, plus multiply the p times the minus q, it's minus pq. Multiply the q times p is plus pq. And then multiply the q times minus q is minus q squared. And that cancels out. And so then you get p squared minus q squared. P squared minus q squared. So p plus q times p minus q is equal to p squared minus q squared. Notice this is an x squared times 36. So this is equivalent to saying x times x squared minus, and 36 is a perfect square, 6 squared, 6 squared. And since it matches the p squared minus q squared, and p squared minus q squared factors as p plus q, p minus q with the letters p and q, that means for every choice of p and q, that expression will factor in that way. So which means that this has to factor as, well, that x and then x plus 6, x minus 6, x plus 6, x minus 6. And we look for that answer, and in fact, it's choice 3. Now we have a 100% way of getting it right plugging into the calculator. I showed you another 100% way of getting it right. The 18 and the times the minus 18 don't multiply to negative 36, which eliminates choice 2 and 4. The fact is that choice 1 is not a cubic. And so we have multiple ways of getting the answer right. Number 2, which equation represents the line that passes through the points -1, 8 and 4, -2? Is it y equals negative 2x plus 6? Or y equals negative 2x plus 10? Or y equals negative 0.5x plus 7.5? Or y equals negative 0.5x plus 8.5? I got another foolproof way of getting this one right. So this is a 100% chance, 100% right, if you just plug in each choice. Literally plug the 2 points into each choice. The one that gets you a true statement for both choices is the answer. Great, which means 100% chance. So where can you get this one wrong, even plugging in and even plugging into the correct one? You can get it wrong by not paying attention to your negative signs and not paying attention to parentheses if they're needed, okay? So my one choice that I'm going to plug in at least every single time is choice 2, unless for any other reason I've eliminated it. Now, would I ever do anything to make smart choices to start plugging in? Well, I might do something like this. -1, 8, I just do a quick rough graph, and 4, -2. I think 4, -2, something like that. I think this slope is going to be more negative than -1, so I think that choice 1 or choice 2 is the answer. But this is a rough graph, so I might not be 100% sure. So, and I also think that in this case, the y-intercept is going to be right below 8, which actually does eliminate choice 2. So I can't plug into choice 2, which is making it way more likely that choice 1 is the answer. Okay? So I've eliminated choice 2. I've eliminated choice 2, by the way, with 100% certainty. Let's talk about the way I cross things out. If I put an x here, and you should borrow my notation. This is actually really good notation. Every student that borrows my notation, it's a very quick 100% way of just quickly noting your things. noting which one you think is wrong or no is wrong, which one you think is correct versus no is correct. If you think the answer is correct and incorrect, you put an X next to it. If you know the answer is incorrect, you put an X there. Think incorrect. And this is if you know incorrect. And then this one, if I put a checkbox here, this is because I think it's correct. And then the classic circling the answer, this is if I know it's correct. Now, I have to now erase. I do have to erase. Do I have to erase? Actually, no. I'm going to take this, Control C, and I'm going to actually go here, Control V, and just so I don't have to erase all that stuff. So now I've actually confirmed, based on this rough graph over here, that the choice with a y-intercept above 8 is incorrect. So actually choice 2 and choice 4 are incorrect. And now this is called what I call a passing problem. Passing problem. I'm not going to talk about a passing problem yet. I'm going to talk about a passing problem later on in the video, just because I don't want to overwhelm you with too many details on just one question. But I know that choice 2 and choice 4 are incorrect because the y-intercept is just too high up. The y-intercept has to be lower than 8. Okay? Which means that I can't just plug into choice 2 because I already know that it's 100% incorrect. So I'm going to plug into what I thought the answer might be is choice 1. I'm only going to plug in one of the points, though, because I don't want to spoil you and make you just move on without seeing how I actually do the problem, because this is a perfect part 2 question, which means you'd have to show work to get full credit. So how do I do this? I could plug into the equation. So I get, again, y equals negative 2x plus 6. I'm going to plug in the first point. 8 is y, and negative 1 is x. A very big error that students make is they switch the x and the y. That's obviously illegal. X, y is called an ordered pair because it literally goes in order. X is the first number, y is the second number. You don't get to change the order of that. So y is 8. 8 is equal to question mark, might be equal to negative 2 times negative 1 plus 6. And another place where students mess up, I talked about parentheses already, but another place where students mess up is they don't know how negative signs work with multiplication. And so if you get questions wrong because you don't know how negative signs work in multiplication, I mean, look, I get it. It sucks that you don't know how negative signs work with multiplication, but you should also just rely on the calculator. Let the calculator do the arithmetic that you know you struggle with, because then you get the answers right. So negative 2 times negative 1, I do what I tell students, predict or verify. I think the answer is positive 2, and in fact the answer is 2, and then I have to add the 6, and I get 8. Okay? And so this is already looking good, so I put a checkbox there. And then what I would do is I would plug in the second point. I kind of already suspect that choice 1 is going to be the answer. I'm not going to plug in the second choice because I'm going to let that leave that up to you, because I need to show you how to get this answer right if it's a part 2 question. I don't want to spoil you by making you not know how to do the problem as a part 2. So the way we do it as a part 2, these are all in slope-intercept form. So pretend that they ask for it in slope-intercept form. If they don't ask for it in slope-intercept form, maybe they ask it in point-slope form. You just give it in point-slope form. So I'm going to pretend they ask it in slope-intercept form. I'm going to call this x1 and y1. I'm going to call this x2, y2. Okay, so the slope is equal to x2. Let me write this in blue. The slope is equal to x2 minus x1. Wow. By the way, I'm not going to erase any single mistakes I make at all. I know that a lot of students request that I make videos for all the regions. And I noticed that sometimes if I make a video for 5 hours or 3 hours, let's say, I spend 10 hours editing, when I could just spend those 10 hours making another video. So I'm going to leave all the errors as they are. So the slope is equal to y2 minus y1 over x2 minus x1. And I plug in the numbers, and this is where parentheses are going to matter. Y2 is negative 2 minus y1, 8, over x2, 4, minus y1, negative 1. Two places where students make an error. They have minus negative 1, and they think they could just keep just one negative sign. You have to keep every negative sign. You have to keep every symbol in the problem. I like to use the word have or keep. You every symbol you have to keep it. I'm sorry, not have or keep. Use or keep. Use it or keep it. Use it or keep it. You have to either use the symbol or keep the symbol. So this negative sign came from the formula, and this negative sign came from the -1. And the second place that students mess this up is when they go to plug it into the calculator. They don't use parentheses. The horizontal fraction bar is a grouping symbol, but the diagonal fraction bar is not a grouping symbol. So how do you get away with you doing a fraction without a grouping symbol? You use parentheses. Parentheses. -2 minus 8, close parentheses, divided by parentheses 4 minus parentheses -1, close parentheses, enter. And the slope is -2. I'm going to show you later on how to put a fraction in the calculator. The calculator can handle real proper fractions, which might be an even better lesson. But I thought it's important for you to know that you need parentheses when cases where you're taking away a grouping symbol. So M is 2, which actually already confirms that the answer is choice 1, since we already know choice 3 and choice 4 are incorrect. But let's keep going. So we know that y is equal to 2x plus b. Now we could plug in any one of these choices to get b. I'm going to plug in the first point. 8 is equal to 2 times -1 plus b. So 8 is equal to, use your calculator to do 2 times -1. I'm sorry, -2. I messed this up, didn't I? The slope is -2, right? Talk about losing negative signs. Fun fact, I'm one of those students who tends to lose negative signs. It's been a long time since I've lost a negative sign. When I say a long time, though, like 3 weeks. Some people do tend to lose negative signs more than others. Unfortunately, more than 50% of students tend to lose negative signs, which means that you're going into this Regents more than likely being one of those students who lose negative signs. I just lost a negative sign, so now I know that I got to be careful with that. -2 times -1, again, is 2 plus b. To solve for b, I subtract the 2, and I get that b is equal to 6. So that the equation of the line is y equals -2x plus 6, confirming choice 1 as the answer. Number 3, a geometric sequence is shown below. 1/2, 2, 8, 32. What is the common ratio? Is it 1/4, 2, 1/2, or 4? This is the problem that I'm going to talk about, a common ratio. Passing problem. I want to talk about a passing problem, but of course I'm going to talk about a common ratio. So what is a passing problem? A passing problem is a problem in which you eliminate at least 2 of the choices. And I'm going to talk about why that I call that a passing problem in a second. The common ratio is a number that you multiply by to get each subsequent answer. Okay? Now I see that I have to multiply by a number bigger than 1. So immediately I see that choice 3 and choice 1 is wrong. Now that I've eliminated 2 choices, if you've eliminated at least 2 choices, that makes this answer a passing problem. Now, choice 1 and problem 1 and problem 2 were also passing problems because I was able to eliminate all 3 choices if I kept plugging into the calculator. So those are also passing problems. But why does eliminating 2 choices make a problem a passing problem? You may have heard that you only need to get half the multiple choice right, and that's it, to pass the test. And that's almost true. Almost true. You need to get a 65 on the Regents to pass the Regents. Now, if you notice, let's zoom in here. Where is the 65? Now, in the test, you need 82 points, raw score points, to get 100. Okay? But how much do you need to get a 65? 29. 29. That's about a third of all the points to pass. Wow. Okay, but how many points, how many problems is 29? Each multiple choice question is 2 points. So 29 divided by 2 is 14 and a half. Really, technically, you need 15 questions to get to pass the Regents out of 24. That's very close to half the questions. So that's why if you eliminate two of the choices, now you've got a 50% chance of getting the question right, which is about, and if you do that with all the questions, you get 50% of the questions right after guessing. That's why I call it a passing problem. Now, you might say, but wait, if I eliminate two choices in every single question, that only uh, uh, gets me half of the 24 questions. That's 12 questions, not 14 and a half or 15. Very close. There's one reply. 12 is very close to 14 or 15. The second reply, though, is that there's going to come questions that you just kind of know how to do. So if you get to other questions that you know how to do, those reduce the number of questions that you have to guess on. Second, if you actually do some of the work on the part twos, threes, and fours, you're gonna eke out a ton of points on the part twos, threes, and fours, and that actually can reduce the number of questions you have to get right on the multiple choice to way below 12, which is why I call these passing problems. Okay, so now does that mean that I get to focus on only the part ones? A lot of teachers do. Even math teachers tell you to focus only on the part ones. That's actually terrible advice for the same reason that I just told you. And if you're a teacher hearing that, that's terrible advice. I'm sorry that I hurt your feelings, but it's true. It's terrible advice. Uh, Notice that what we just did in the part ones to get the question right is identical to what you would do on a part two. If you're focusing on only tricks to get the answers right, to get as many points as possible, now you're having students memorize tricks when they could just memorize methods to get the answers right. Which one's better? Methods get you a higher score. Tricks, most of the time, don't even get you passing. You know how many students I know who've gotten like a 63 on the Regents, take Algebra 1 all the way again a whole year, and then get a 62, which means they literally learned nothing the entire year because they focus on tricks only instead of methods. Am I passionate about that? I don't know. You tell me. So I've already turned this into a passing problem because I guarantee that I have to multiply by a number bigger than 1 to get each step. In fact, it looks like I have to get from 2 to 8, I have to multiply by 4. To get from 8 to 32, it looks like I have to multiply by 4. I'm pretty sure that that's going to be the answer. I'm pretty sure that 2 is not going to be the answer. Now, why am I not just circling 4 and moving on? Because you need to see. And by the way, if I were you, I would circle 4 and move on. I just showed you how that it's 4. And in fact, a half times 4, confirm it on a calculator, is 2. A half times 4 is a half of 4. Half of 4 is 2. So that does work. However, we need another way to calculate it if this were a part 2 question. What you could do, so why is it called the common ratio if I'm not multiplying by a number? If I am multiplying by a number here, why is that called the common ratio? It's called the common ratio because it is the ratio of subsequent terms. The next term divided by the current term. The next term divided by the current term is all the same common number. If I do 8 divided by 2, that's equal to 4. If I do 32 divided by 8, that's equal to 4. And if I go in my calculator and I'm careful with my parentheses, and I do 2 divided by parentheses 1/2, that with parentheses, that's equal to 4. And if you don't believe it, and you did it on your calculator, and your calculator says, no, that's not true, I'm going to say you didn't use parentheses. So this is how to calculate the common ratio. It's a sub n plus 1 divided by an. So this is equal to a2 over a1, which is equal to 2 divided by 1/2, equal to 4. Or equal a3 divided by a2, which is equal to 8 divided by 2, which is equal to 4. And 32 divided by 8, that's equal to 4. Okay, so that's how to get the common ratio. If you choose to subscribe, I really do appreciate it. Again, I am finally past, when this shows you, the 1,000 subscribers. I'm past, I got 1,240. I don't have, if you see ads on this video, I don't get the money for those ads. Google does put ads on videos, even if you don't have ads on them, because they have minimum requirements, like 1,000 subscribers, and I think 4,000 watch hours in a calendar year. So you watching this video gets me also closer to getting those ads to actually give me revenue. I do this for free, but I make my money through tutoring, JuanTutors.com. But you see, I have 256,000 views already. but they correspond to views over the course of my entire YouTube career. Right now, I don't have 4,000 watch hours in a year. So if you're enjoying this video and it's working for you, please do subscribe, like, comment, all that. It does help other students find this video so that they can get better at math as well. Number 4, what is the constant term of the polynomial 2x cubed minus x plus 5 plus 4x squared? Is it 5, 2, 3, or 4? 5, 2, 3, or 4. So this says the constant term of the polynomial 2x cubed minus x plus 5 minus 4x squared. Well, I'm going to say 3. I see why a lot of students might say 3 because the first term that's written is has a 2x cubed, but that's the exponent. That's one problem, not the term. So 3 is actually not the answer, okay? But there's actually a bigger thing to know. The terms of a polynomial, you have to know what the leading term is, and you have to know what the constant term is. That's just at a minimum. You might say, and so you might say that the leading term is 2x cubed, and you might be right, but you might be wrong, especially in this kind of problem. Of course, the answer is a definite yes or a definite no, but I will tell you this. If you notice that the terms are scrambled here, they're going to ask you about the constant term, but they're going to scramble the terms. They're going to ask you about the leading term, but they're going to scramble the terms. And so you have to know that when you say the leading term and I say the leading term, we have to agree no matter how we scramble the terms. And there's only one way to write the polynomial so that we can identify what the leading term and the constant term is. You have to write this, in decreasing exponent order. You have to write this in decreasing exponent order. So I see a cubed is the highest degree term, so I write 2x cubed. Then the squared is the next lowest degree, so I should do plus 4x squared. And then I see the next lowest degree is the minus x. That's minus x to the first, so it's minus x. And then I get a plus 5. Okay. Now, there is a fun fact that you can get the constant term by plugging in x equals 0, and that will confirm with 100% certainty. Constant term is equal to the value when x equals 0. It's equal to the value when x equals 0. Okay, so that gives you a 100% chance of getting the question right, which means that there is no plugging in of these choices. You literally just plug in x equals 0 and it'll tell you the answer. But now, what is this 2? This 2 is not the constant. This is the leading term. This is the leading term. That's equal to 2x cubed. And so the leading coefficient is equal to the coefficient of the x cubed, which is 2. And so what is the constant term and the constant coefficient? Constant term is equal to the constant coefficient. These are actually equal to each other because there's no x involved, and that's equal to 5. The leading term and the leading coefficient are not the same because there's an x involved. But the constant term, there's no x involved. The constant term is equal to the constant coefficient, which is equal to 5, which is choice 1, and we move on. Get a sip of water. As I said, I'm literally leaving every cough, every error, because no editing means I can get more videos out. Number 5, a landscaping company charges a set fee for a spring cleanup plus an hourly labor rate. The total cost is modeled by the function c of x equals 55x plus 80. This happens to be pretty close to what my landscapers charge. In this function, what does the 55 represent? Is it the set fee for the cleanup, or is it the hourly labor rate for the cleanup, or is it the profit earned by the company for one cleanup, or is it the number of hours of labor required for one cleanup? Okay, so these all can mean actually can be thought of, uh, can be considered here, but not every answer is appears. Okay, so um, for choice one, well, I said that I would. Okay, so is it? So looking at the cost, it's 55x plus 80. 55x plus 80. I see that if I increase the number of hours, that increases the amount that I get charged by 55 each hour. 1 hour, another 55. Another hour, another 55. Another hour, another 55. And then I see that the 80 seems to be this fixed number that just appears even if there's 0 hours of work. So I think that so the set fee for the spring cleanup is 80. That's because that's a set fee, unchanging, unaffected by the number of hours. Okay. Now, so that's 80. Now the hourly labor rate for the cleanup, that's the 55. Now the profit earned by the company for one cleanup. This problem doesn't actually talk about the profit. It talks about the revenue. So the revenue is equal to 80. In another problem, they might talk about the profit. The revenue for one cleanup is 80. The profit, well, we don't know. Now, the number of hours of labor required for a cleanup, we don't know because of cleanup is a fixed cost. Okay? Um, so it doesn't appear. Okay? So, but they asked again the hourly labor rate, or what does the 55 represent? It actually represents the hourly labor rate. And so other things appear in the problem, but since that's all they asked for, choice two is the correct answer. And notice that we actually identified a way to eliminate choices in that problem by identifying what they actually are in the equation. That's how you eliminate other choices. Okay? So every single question, I'm going to do my best to give you a way to eliminate choices. And I think that I do that successfully for every single problem. Number 6, which expression is equivalent to 5x squared minus 2x plus 4 minus parentheses 3x squared plus 3x minus 1? Is it 2x squared plus x plus 3, or 2x squared minus 5x plus 5, or 2x to the fourth plus x squared plus 3, or 2x to the fourth minus 5x squared plus 5? Yet another one that you could do by plugging into y equals. So 100% to get this question right without knowing how to do the problem, plug into y equals. Another 100%, plug in test values. Now, I'm going to plug in some test values for this one just so you see the process. What are the choices for test values? There's actually two sets of good choices for test values. Two sets of good choices for test values. Easy are like 0, 1, or maybe roots. If you happen to see a quick root of a polynomial, uh, and so anything else that you know is going to be easy to plug in. With 0 and 1 tends to be very easy to plug in, and then roots tend to be easy to plug in because you happen to know that when you know that factors are multiplied to 0, and other ones are, I'm not going to say difficult because numbers tend to be not too difficult to plug in, especially if you use integers, but I'm going to say rare, meaning rare numbers are numbers that would be more likely to identify the answer in one step with 100% certainty, like 9 or 11, or not in geometry class, but Algebra 1 class, or not in Algebra 2 class, maybe like pi, or a decimal, 1.1, or even 10 is a little bit rare, but they do kind of make 10 a little less rare. But what's my point? If you plug in 0 and 1, it's often the case that you can't eliminate every choice, but you can eliminate some very quickly. That's the benefit. You won't be able to eliminate all the answers, but you'll be able to eliminate some very, very, very quickly. Okay, so I'm going to show you plugging in what happens when I plug in x equals 0. So if I get x equals 0, I get parentheses 0, 0, 0 plus 4 minus parentheses 0, 0 minus 1. And I have to go to my calculator and I get 4 minus -1. I'm not going to simulate plugging in 4 minus -1 into my calculator because at some point you got to get used to just accepting when you are or are not good at certain arithmetic. You know, I used a bunch of, I guess I am going to simulate it apparently. 4 parentheses minus parentheses -1, close parentheses, enter, and I get 5. But I happen to know that 4 minus -1 is 4 plus 1, which is 5. Since I plug in x equals 0, if I plug in x equals 0, I get 3, I get 5. Here I get 3, and I get 5. If I get 3, I know I'm supposed to get 5, so I know any choice that gives me a 3, or not a 5, when I plug in x equals 0, is got to be incorrect. Now, notice very easy number to plug in, 0. Very quickly eliminated choice 1 and 3, but it didn't eliminate every choice. Most likely, though, if I plug in x equals 1, most likely, if I plug in x equals 1, it'll confirm which of these two answers is correct. So, or if I plug in 9, that gives just, I'm not going to, again, simulate that part because now you know how to do it. But I'm going to leave it up to you to remember that you could plug in test points during the Regents. No one's making you do the problem doing algebraic methods on the part 1s. However, this is very much a part 2 question. How would they word it in a part 2? They might say, write an expression, write a polynomial expression that is equivalent to that polynomial in standard form. They might say it that way. And so how do I do this problem in part 2? Or now in a part 1, but algebraically. So 5x squared minus 2x plus 4 minus parentheses 3x squared plus 3x minus 1. It helps a lot of students to put in a 1 in front because they're so good with the distributive property. They put in a 1, distribute the 1. And here now they distribute a minus 1. And then they get, and notice I distributed to everything, then they get 5x squared minus 2x plus 4, and then minus 3x squared minus 3x, and then minus negative is plus 1. If you don't know -1 times -1, go to your calculator, let your calculator do it. And then they combine like terms. So 5x squared minus 3x squared is equal to 2x squared. And also minus 2x minus 3x is equal to minus 5x. And then let's go in blue over here. Plus 4 plus 1 equals plus 5. And so then I get my answer using all of these terms. 2x squared minus 5x plus 5, which is choice 2. All right, party time. Number 7, a system of inequalities is graphed on the set of axes below. Which point is a solution to the system? 1, 1, 2, -2, 1, 8, 4, 2. This one is, I am going to plug in all of them because really this one, that's the only way to do this one. You literally have to look at the graph, look where the points are, and then decide based on that which one is a solution to all, to both the system of inequalities. So 1, 1 is the point right there. Okay. So just to address the mistake that a lot of students make, notice that I drew my dot. Can I zoom into this like so 100%? Okay. So notice I drew my dot right on the crossing between the two lines. A lot of students make the mistake of like drawing it like over, under, to the left, to the right of where it actually is supposed to be, and that's illegal because for a point to be graphed correctly, it has to be exactly where it's supposed to be without being to the left or to the right of it. Okay? So, let's see. View 100%. Okay, there we go. Okay, so that's the 1, 1. Then the point 2, negative 2 is right there. Then the point 1, 8 is all the way up here. So 1, 1, 2, negative 2, 1, 8, and then the point 4, 2, 4, 2. It's funny because if you were the kind of student who didn't know what this meant, like you still might end up guessing 4, 2 as the correct answer. And you'd be right, wouldn't you? So what does it take for an answer to be a solution to the system? It must be in both shaded regions. And a special note, though, the shaded regions, a darkened in line is in the shaded region. And a dotted line is not in the shaded region. Okay? So a dotted line, a dotted line is not in the shaded region, but a dark line is in the shaded region. Why do we do that? Well, because when we get to the border, we have to signify whether the border is part of your region or not part of your region. But we have to draw the border no matter what. So we actually have to create a symbol for that border, and so, which states whether it's shaded or not. So a border that is shaded is dark solid line, which includes this solid line here. A border that is not in the solution set would then be drawn as a dotted line, which is this. So if you notice, two of these answers are on the dotted line. Here, dotted on the dotted line. So they're on the dotted line, which implies that they're not in the solution set. Okay, so that means that 1, 1 gets eliminated and 2, negative 2 gets eliminated. Nice. Now we have a passing problem. And what about a solution to the system then? Is it choice 1, 8 or 4, negative 2? Notice that 1, 8 is in only one shaded region. It's in only one shaded region, which implies that it's not in the solution set. Which means that 1, 8 gets eliminated too. And 4, 2 is in both shaded regions. Which implies that it's in the solution set. Which leaves choice 4 as the only correct answer. Number 8. In an arithmetic sequence, the first term is 25 and the third term is 15. What is the 10th term of the sequence? Is it negative 20, negative 25, 70, or 75? Okay, so I know some answers that I'm going to eliminate really very quickly. You kind of have to know what an arithmetic sequence is, but even if you don't, and if you knew how sequences work and there has to be a pattern involved, most likely you're going to eliminate two of the choices. So it goes 25, then a blank, and then 15 at the third term, then blank, 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 blank. So this is term 1, 2, 3, 4. I'm going to write those numbers in a different color so that we know that this is not a division. This is just a labeling. This is the first. This is the second. This is the third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Okay. Well, even if you assume that this was like a geometric sequence or something like that, which it's not, you'd be getting a smaller number, and choice 3 and choice 4 would be bigger, which means that they can't be it. But the other thing is, if you're doing an arithmetic sequence, if it's like an addition problem, well, the answers are getting small. The numbers are getting smaller, 25 down to 15. So the numbers are getting smaller, which means the final answer definitely is going to be less than 15. Eliminating for sure choice 3 and choice 4. And now we have a passing problem, which is nice, pretty sweet. Okay, so what about which one's the answer choice? Is it negative 20 or negative 25? I strongly suspect I'm liking this answer more than this answer. And I'll tell you it's because of the pattern. I think it's going to go at the ending digit 5, 0, 5, 0, 5, 0. So I think the odd terms are going to have a 5 and the even terms are going to have a 0 at the end. So I actually just literally misspoke. I was thinking it correctly, and I said it incorrectly. I think that the even terms are going to end in a 0, the odd terms are going to end in a 5. And this one, now talking about a 100% method, we just eliminated two choices with 100% certainty. But if you don't remember what a arithmetic sequence is versus a geometric sequence, you might struggle. But the truth is that if you didn't remember which one was which, you'd still be able to answer something. You might be able to say something, because you might say, well, if this is a geometric sequence, this answer should be closer to 0, not negative something bigger than 15. Which means that you would say, oh, it's not geometric, it's the other method, the other type of sequence that I learned, and then you might be able to construct a sequence. So how do you do this problem fully? Like if this was a part 2 question, or the fact is right now we're stuck on how to do the problem, and the best way to get this problem is by doing a method that is correct. An arithmetic sequence is you're adding a fixed number to the current term to get the next term. And so the question is, what number do you have to add to 25 to get to this number, and then add the same number to this to get to this number. Notice that if I'm adding the number twice, I'm adding twice to get from 25 to 15. To get from 25 to 15, I have to add 10, negative 10. I have to add negative 10. So to get from 25 to this number, I have to add half of that, negative 5. And then I have to add negative 5 to get to 15, which means that this number is going to be 20. This number is going to be 15. And I was going to say, because of that, the other way that you could do it, if you know that an arithmetic sequence is adding a fixed number, you could just create the sequence and just literally fill it in. Okay, but if this is a part 2 question, you have to also know how to get the answer numerically, or even if it's a part 1 question, because they were kind and said, what is the 10th term? But what if they didn't ask for the 10th term? What if they asked for the 57th term? Can you do it this way that I just did? Yes, that's actually legal, even on a part 2 question, unless they tell you it has to be an algebraic method. But if it's the 57th term, you're going to be writing a lot. So how do you do this algebraically? So if you get a1 is equal to 25, and an is equal to an minus 1, an minus 1 plus negative 5, that means that I'm adding I'm adding negative 5 to a1 n minus 1 times to get to an. So an is equal to a1 plus n minus 1 times negative 5. So this is equal to 25 plus n minus 1 times negative 5. And I could use this formula to get that 10th term. A sub 10 is equal to 25 plus parentheses 10 minus 1 times negative 5. And so that, using my parentheses, 25 plus 9 times negative 5. Using my calculator, if I don't know how to work with negative numbers, 25, 9 times negative 5 is minus 45. And then using my calculator again to get 25 minus 45 is negative 20. Groovy. Full credit. Full credit. Okay. So number 9. When the formula P equals 2L plus 2W is solved for W, the result is W equals 2L plus P over 2, or W equals P minus 2L over 2, or W equals P over 2 plus L, or W equals L minus P over 2. And you might wonder, can I do this problem by plugging in numbers? And you absolutely can. First off, do know that this is the formula for the perimeter of rectangle. Okay, so that might be useful for you. However, what if you wanted to do this problem by plugging in numbers? Oh, well, you could actually choose your L and W. I might even choose rarer numbers, like 9. And so 2 times 9 plus 2 times, I don't know, 15 equals the perimeter. And I go to my calculator and I get 15 times 2 is 30 plus 18 is 48. So I got that L is equal to 9. P is equal, no, W equals 15. And then P is equal to 48. And the answer that has those as the as a true solution is very unlikely to be more than one of the choices. Now, I promised you that I would always plug into 2. So let's actually see if these satisfy choice 2. 15 equals P 48 minus 2L, 2 times 9 over 2. And you could use your calculator, use your parentheses very carefully. So use as many as you need. Never use less. By the way, the trick to parentheses is not that you should use as few parentheses as possible. And that's the mistake that students make. They try to reduce the number of parentheses they use. In fact, most students know how to use parentheses. Use more parentheses and don't use them illegally. So you should never actually try to just not use parentheses. You should actually be actively trying to use more parentheses. Just make sure that not to use them illegally. And it's really rare. It's really rare for a student to use extra parentheses illegally. It's extremely common for a student to not use parentheses illegally. Okay, so I get 15 here is equal to, the numerator is 48 minus 18 over 2, which is equal to 15 is equal to 30 over 2, or 15 equals 15. 2 is looking very good. And I would bet that some of these answers are going to be incorrect. Actually, there's already enough to verify that this answer is incorrect, because this answer is going to be bigger than 24 with these choices. This answer is going to be bigger than 24. And in fact, this answer is less than 0. So already choice 2, choice 3, and choice 4 are not looking good. Choice 2 is looking like the only one that is correct. But we do need to know how to do this problem algebraically. That was your exchange. By the way, we just got a way to do the problem with 100% certainty. Yet another problem that we could do with 100% certainty. Plug in some test choices. So how do I do this on algebraically though? So P equals 2L plus 2W, and I want to solve for W. I need to eliminate everything around W in using the operations that are written to them. So 2L is being added to 2W, so I'm going to subtract 2L. And I get that 2W equals P minus 2L. And now W is being multiplied by 2. I have to divide W divide both sides by 2, and I get exactly that. So what the answer is. So W is equal to P minus 2L over 2, which is exactly what we thought it would be, is choice 2. With 100% certainty of getting that question right. You know, not bad. And we did that with so many questions. Why do I think that my videos are superior to other videos? Because I actually show you how to get better scores, even if you don't know how to do the problem. If you're like rushing to get the answer and to get the best score on the Regents in like 2 days, I think my video is one of the best videos there are. I'm not even being conceited about it. Number 10, Market Street Pizza kept a record of pizza sales for the month of February. The results are shown in the table below. And I do a quick read of the table, and then I come back to it later. I see type thin crust, deep crust, plain veggie, meat only works. I see 380, 120, 100, 225, 105, 70. Not all of that stuff made it into here. I just always look at the table quick and then move on. Okay, then it says, of all the pizzas sold in February, what percent were plain deep dish pizza? 20%, 30%, 40%, 50%. Plain deep dish of all of them. So I see that 200 out of all of them are plain deep dish. Is that half? I already see that plain thin crust is more popular than plain deep dish. It's not going to be 50%. Now I got a 1 in 3 chance of getting the question right, which is phenomenal. Okay, so you might not like me eliminating just one answer, but the truth is that if you kept going, you could actually do things to eliminate more answers. Like 300 and 100 is 400. So 200 plain deep dish and at least 400 of other types. That's a third. So the answer is less than 33%. That actually eliminates choice 3. Now we have a passing problem. We've eliminated 2 choices. And with the other ones, I suspect that 30 is a little bit too small. I'm sorry, a little bit too big. So I'm already liking choice 1 rather, 20%. Notice my X on the number 3 and the number 4 because I know that they're incorrect. And I put an X next to choice 2 because I think as a fake student, I'm pretending I'm a student. I think that choice 2 is incorrect. And I suspect that choice 1 is correct. So I put a checkbox next to it. Okay. So how do I do this problem? I have to know how to get a percent. So percent is equal to part over whole times 100. Okay. And so the part is 200 over the whole. I'm going to make a big fraction. Okay. So 200 plus 300 plus 80 plus 25 plus 120 plus 105 plus 100 plus 70. All of that times 100. And probably a smart idea to go to your calculator and add all these numbers up. They did make the numbers carefully add up to exactly 1,000. So it's 200 over 1,000 times 100. Let's scroll up a little bit. Times 100. That barely looks like 100. And if I do that and I do that, I get 200 over 10, or I go on my calculator, it's 20%. 20%, which is exactly choice 1. Number 11, when solving -2 parentheses 3x minus 5 equals 9 over 2 times x minus 2 for x, the solution is 8 over 7, 10 over 11, -16 over 21, or -16 over 3. Now, I'm going to use this problem. I promised that I would show you how to plug in fractions, proper fractions into the calculator, and this is the problem that I'm going to use for that. Just because I want you to know that one way you could do this problem is by plugging in the answers. And plugging in the answers is 100% guaranteed. It's 100% guaranteed that you're going to get the correct answer. So we've actually gotten to almost every question that you can get 100% guaranteed correct, which is great, but we also have to show how to do it algebraically, of course. So -2 parentheses times parentheses. I found out when I was doing a test, this test process, that you actually do have to put the multiplication symbol between the number and the fraction. 3 times math number. So the way to put the fraction, press the math button, go to the next column, go to number, and the very last option is n over d. And look at that, that puts a fraction in there. proper fraction. So we put choice, I promised that I would always test choice 2, so 10 over 11 minus 5, close the parentheses, press enter, and we get 50 over 11. And when you plug into the second part, again, the second half of the equation, math, number, the last column, n over d, this is a 9 over 2, and look at that, that's a proper fraction. So the horizontal fraction bar here is a grouping symbol. 9 over 2 times math, number, again, n over d, 10 over 11, then minus 2, and I get 23 over 11. 23 over 11. So the answer is not, the answer of choice 2 is not correct, because on one side we get 50 over 11, and on the other one we get 23 over 11. Okay? So, but what about if you wanted to test another answer? Suppose you wanted to change this to test choice 3. So the benefit in plugging it in, you might say it takes a long time to plug it in, but look what happens if I want to change the answer to choice 3. I do negative 16. So now I could just change the numbers, 21, enter. And now, what about the second one? I have to change the 10 over 11 to a negative 16 over 21. And I get a different answer. So choice 3 is also not correct by plugging in. So, and now you know how to put in proper fractions into the calculator, which I think is super. So of course, this could be a part 2 or maybe even a part 3 question. So we do have to know how to solve this one algebraically. So what I'm going to do is I'm going to distribute the negative 2 to get rid of the parentheses. And I get negative 6x minus 2 times minus 5 is plus 10 is equal to 9 over 2 x minus 2. And now to solve the equation, I'm going to subtract 10. Maybe I'm afraid of how to work with fractions, but I at least know I can subtract 10. So always when you don't know what to do with one piece of it, but you know what to do with another piece of it, do the part that you know how to do. Never stop until there's nothing left for you to do. You know how many times I've worked with students and they're like, I don't know how to do this question. I'm like, do you know how to start it? Sure, but I don't know how to finish it. Well, you don't know that you don't know how to finish it because you haven't started it. Do the step that you know how to do, because sometimes you don't know how to finish it, but you could do one step. Then you don't know how to finish it, in quotation marks, but you could do one step. And then you don't know how to finish it, but you could do one step, and suddenly you're 3 steps in, and then 4 steps in, and 5 steps in, and suddenly you're at the last step, and you're like, oh, I just divide, or something like that. Or I just add, or I need my calculator because I don't know how fractions work, but the calculator does. Okay, so here I get negative 6x is equal to 9 over 2x minus 12. Then now I know the answer is going to be positive because, well, I don't know yet. Maybe I know the answer is going to be positive, but maybe you don't know yet. But I'm going to subtract 9 over 2x. I'm going to subtract 9 over 2x. And this is the part that students might struggle with, but the calculator doesn't. So if you do negative 6 minus math, number, fraction, 9 over 2, okay? You get negative 21 over 2. So you get negative 21 over 2x is equal to negative 12. And now, this is the point where I know that choice 4 is incorrect because now a negative times a positive is negative, but a negative times a negative is positive. If x were negative, this side 12 would be a positive 12 or a positive number. But since that 12 is a negative 12, that x has to be a positive number. So other students might struggle at this point because I'm like, they might be like, I don't know how negative or how fractions work. But the truth is, the calculator can handle dividing by negative 21 over 12 over 2 by plugging it in as a proper fraction the way I just taught you. But I want to show you yet another way. You can get rid of the divide by 2 by multiplying by 2. And you get those cancel. And you get negative 21x is equal to negative 24. Now you divide by negative 21. Okay? And the calculator will tell you. Now, look at this also. The calculator can also turn a decimal into a fraction. Negative 24 divided by negative 21. You get this decimal, which might be frustrating, but if you go to math, the very first option at math is convert to a fraction. Arrow frac, convert to a fraction, 8 over 7, which is the choice that we suspected. Number 12, the expression x to the power of 2a plus b is equivalent to x to the 2a plus x to the b, or x to the a plus x to the a plus b, or x to the a times x to the a plus b, or x to the a plus b times x to the a plus b. So some students who know how exponents work will still get this question wrong because they'll say the answer is 4. And that actually, for me, as a fake student who knows how multiplication works, I happen to know that that 2 is multiplying the a, but it's not multiplying the b. So here, because the x would be having, the 2 would be having the same operation on the a and the b, choice 4 is looking very bad to me as a fake student. As a fake student also, I might be saying to myself, I don't remember the exact exponent rules, but I do remember that an exponent, an addition in the exponent, is equivalent to a multiplication at the base level. Since these have pluses here, those are wrong, which makes choice 1 and choice 2 fully incorrect. Now, how would I do this problem? So by the way, I just turned this one into a passing problem because I just eliminated 2 of the choices. How might I do this problem with plugging in? This one can be done with plugging in. You could just choose rare values of x and a and b. Let x equal, let's say, 9, a equal 8, and b looks like a 6. And plug those numbers in. And so then you get 9 to the power of 2 times 8 plus 6, and see what the calculator spits out, probably a big number, and then see which of these two answers gives you the same exact answer. 100% chance. I just gave you a way to do it by knowing that addition in the exponent is a multiplication at the base level. That eliminated 2 answers, but plugging in test values just gives you the answer with 100% certainty. By the way, is this really 100% certain? Actually, it's probably more like 99.9% certain. But the truth is, I'd have to be extremely unlucky to choose numbers that are rare, but also give me 2 of the answers that are exactly the same. So what happens though? How can I turn that a 99.9% chance of getting the answer right to a 100% chance of getting it right? If I get 2 answers that are exactly the same, then I probably should just pick 3 sets of other numbers and see which one matches. The other thing I could do is I could choose the easy numbers. Let x be 9, and then let a and b both be like 1 and 2 or something like that, or 0 and 1, the easy numbers to plug in, and see which one gives me the correct answers. And that won't eliminate every answer, but it would eliminate choice 1 and 2 for sure. And if I let a be 0 and b be 1, I think that actually eliminates all the incorrect answers. So there. So that I like the plugging in method as a choice to eliminate answers. How do I do this problem? You have to know this. So now we're actually doing the problem. You have to know these 2 properties to get answers right on the regions. X to the p plus q is equal to x to the p times, let me repeat. You have to know these 2 methods to get answers right on the regions. X to the p plus q is equal to x to the p times x to the q. And also you need to know that x to the p, that to the power of q, is equal to x to the p times q. Okay, so those properties are both going to be used in this problem. So here I have x to the 2a plus b, x to the 2a plus b. According to the first rule here, this is equal to x to the 2a times x to the b. And that eliminates choice 1 and choice 2 already because those have addition and not multiplication. And then the 2a is equal to a plus a. And so by rule 2, this is x to the a squared times x to the b. By rule 2, okay, the a plus a is so you could use rule 1. The x to the a squared, so you could use rule 2. So either by rule 1 or rule 2 here, I get this is equal to x to the a times x to the a times x to the b. And that is looking like it's going to eliminate choice 4. But by rule 1, I can go the other way around, not just split things up, I can combine them. By rule 1, well, x to this first x to the a is not affected by rule 1, but the x to the a times x to the b by rule 1 is equal to the x to the a plus b, which now that does match choice 3. Isn't that nice? One way of getting it right by just taking test values, one way of getting it right by doing the algebra. We are very quickly approaching a passing grade on this test. We've already gotten 12 questions right, which is 24 points. 24 points. So that's phenomenal. Number 13. The inputs and outputs of a function are shown in the table below. And I do quick glance at the table. X 0, 1, 2, 3, 4, 5. F of x 0.0625, 0.125, 0.25, 0.5, 1, and 2. I think I see a pattern there, but I'm going to not process it until later. It says this function can best be described as linear, quadratic, exponential, or absolute value. One thing I know that it's not linear, because linear would imply that if I'm adding 1, which is what I'm doing on the x coordinates, if I'm adding 1, then I would have to be adding the same number on the left side, not the plus 1, but just the same number all the way up and down the y coordinate. This is plus 1, but here from 0.5 to plus 1 is plus 0.5, not 0.1, so it's not linear. Okay, I'm going to erase that now. But I think I do see a pattern though. I do see a pattern that these are doubling. Times 2, times 2, times 2, times 2, times 2. This is this is an important fact to know. Exponential functions functions with NC TIONS. They're basically equal to, in quotation marks, but very, very thin quotation marks, are equal to geometric series. And with quotation marks, very thin quotation marks though, in that if you just plug in the integers for x, the y coordinates get multiplied by a fixed number. That's literally what exponential functions do and also what geometric series do. So this is definitely going to be an exponential function. But what if this was a part 2 question and they wanted to know what the function is? Well, now we know, since we're multiplying by a fixed number 2, this is going to be the function f of x is equal to some number a times 2 to the power of x. And so how can I get the value of a? I can plug in f of 0, let's say, is equal to a times 2 to the 0. And so I get 0.0625 is equal to a times, now 2 to the 0, you do have to know this, 2 to the 0 is equal to 1. And actually, do you have to know it? You shouldn't guess. You got a calculator, right? You could plug it into your calculator. You should never guess at things that your calculator can confirm, right? You're like, I think 2 to the 0 is, a lot of students are like, oh, I think 2 to the 0 is 0. Other students are like, I think 2 to the 0 is 1. The moment you hear both and they both seem plausible, you should just go to the calculator, find out 2 to the 0, it's 1. So 2 to the 0 is equal to 1. And so that a is equal to 0.0625. And so f of x is equal to 0.0625 times 2 to the x, giving us the exponential function. Okay. Number 14, Stephanie is solving the equation x squared minus 12x. Oops, Let me reread. Misread. Number 14. Stephanie is solving the equation x squared minus 12 equals 7x minus 8. Her first step is shown below. Given x squared minus 12 equals 7x minus 8, and in step 1, x squared minus 4 is equal to 7x. Which property justifies her first step? Is it the associative property, the commutative property, the distributive property, or the addition property of equality? So a lot of students try to guess at this answer without actually even trying to analyze what her first step was. You actually have to know what she did. What did she do? I see that the minus 8 is gone. So and the point that I'm making is I can't eliminate a single choice here without actually looking at what she did. So what did she do? She added 8 to both sides of the equation. And then she got x squared minus 4 is equal to 7x. So what allows her to do that? Is it the associative property or the commutative property or the distributive property or the addition property of equality? Now, I will say this. This is an extremely rare situation. I haven't said this, I think, in a single Regents video ever. You have to choose the best answer. Because there is an associative property happening here. Like you're adding the negative 12 and the 8, granted. But what the question is, what is it that even allowed her to add 8 to both sides of the equal sign? What allowed her to add 8 to both sides of the equal sign is the fact that when you have an equation with an equal sign, if you add the same number to both sides of the equal sign, you get a new equation that is also correct. And that is the addition property of equality. I accidentally crossed that out when I meant to underline it. That's the addition property of equality in an equation. And I'm going to say this in a generable way, meaning a way that creates solutions. You can add the same number to both sides of the equal sign. Okay? So now we have that. Let's go to number 15. And we are now celebrating a passing grade. This is the problem that's going to give us the passing grade. We haven't even done the part 2s, 3s, and 4s, but we got a perfect grade on the part 1s up to 14. And number 15 is going to give us that 29th and 30th point that we analyzed earlier is going to give us the passing grade. So we could celebrate here right now. We are passing this test. Number 15, what is the sum of 8 radical 3 and radical 3? Is it 8 radical 6, 9 radical 6, 7 radical 3, or 9 radical 3? And I love that this is the question that's going to give us the passing grade, because as much as I want you to know how to do this problem, you can literally go to your calculator and just do it. This is a 100% chance. There's a 100% chance of getting it right. Just plug into the calculator. You do need to know that the word sum means addition. Okay, plus. So you go to your calculator, and I'm going to test number 2, as I always do, because that's the one that my random number generator is set to start with. So I do 8 radical 3. We're about to pass this test. Already passed. Plus radical 3. And I get this decimal. And if you try to convert this to a fraction, assuming there is an interesting bug in the calculator that it thinks some decimals are fractions when they're not. So I'm not going to test whether this tries to convert it to a fraction or not. I got caught with that in a video. Anyway, it was like I was trying to demonstrate this number is irrational, and the calculator pops out a fraction. I wasn't wrong. The number was irrational, but the calculator has a certain way of identifying whether numbers are rational or irrational, which means that sometimes it's just wrong. It's not 100% foolproof. So now this is 8 radical 3 plus radical 3. I'm going to test number choice 2, because that's what I said I would choose. It is a little bit too big. I actually do already know that choice 2 is incorrect because 9 radical 6 is bigger than 9 radical 4, which is 9 times 2, which is 18. So it's bigger than 18, which is not 15. So anyway, so now it's 22. So this is around 15 point, what did we say? 15 point uh, 58, 8, 8. And this is around 22. So that one's incorrect. So now I have to look for answers that are smaller. So 9 radical 3 plausibly is it? Well, actually, all of these are smaller, but I see 8 radical 6 is just a tiny bit smaller, or maybe like 20-ish. I don't know. But I did see 8 times radical 6 is bigger than 8 times 2, which is 16. The answer is around 15. This one's already confirmed incorrect. Now I have a passing problem. I'm loving all the strategies that we have. So how do we do this problem? And so we do this by acknowledging that we have the same radical. We can actually treat the radical 3 as a variable. 8 radical 3 plus radical 3 is the same thing as 8 radical 3 plus 1 radical 3, which is equal to 8 plus 1 radical 3, which is equal to 9 radical 3. And we've passed this test. We've passed this test. Congratulations. Congratulations on passing this Regents. Number 16, the dot plots below represent test scores for 20 students on a math test. And I do take a quick look. I see 60 to 100 for all the 4 Roman numerals, and I see the dots distributed in a bunch of different ways. And it says the mode for this math test is 80, and the median is 85. Which dot plot correctly represents the data? Is it Roman numeral 1, 2, 3, or 4? So I see Roman numeral 2. That one is easy to eliminate. Roman numeral 2 is perfectly symmetric. So the mode is equal to the biggest number, which is 80, very visually identifiably 80. But because the data is also symmetric, the median is equal to 80. So that at least allows me to quickly eliminate one of the choices. Okay, let's see. Are any of the others eliminable? Okay, here I see that the mode is 80. I think the mode is the easiest to identify, so let's actually go that way. Mode is equal to 80. Here the mode is equal to the most common, remember the mode is the most common, which is equal to 85 in this case. The most common data point, or the data point that occurs the most likely, is 85. So this one is incorrect. This one is incorrect. And here, the mode is 85. Okay. So here is also incorrect, which actually already, just by identifying the mode and one quick easy median, we've eliminated all the incorrect choices, leaving only choice 1 as the answer, which is great. But we have to identify how we identify the median. So the median is equal to the middle number when the data points are in order, is in increasing order. And so how do we identify the middle point? I like to put slashes around the data. So I cross out a number in the beginning, cross out a number at the end, cross out a number at the beginning, cross out a number at the end, and I keep following the pattern, crossing out simultaneously beginning and end, because sometimes you do end with 2 middle numbers, and that matters. Okay, beginning and end, cross out, 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 beginning and end, cross out. Look at that, 2 points in the middle. And so what do you do when there's 2 numbers in the middle? You take the median is equal to the average of the 2 middle numbers if there are 2 middle numbers. If there's only 1 middle number, well, the median is that one number. So in this case, though, the median is equal to the average of those 2 numbers, which are both 85. over 2, which is equal to 85. So the median is 85. And in fact, just like we expected, choice 1 is the correct answer. All right. Number 17. A function is graphed on the set of axes below. And I look at the graph real quick. I see an open circle and I see, okay, I see it's increasing from -2, -4, increasing, and then maybe plateauing. And it says the domain of this function is x such that x is greater than -2, or x such as that x is greater than or equal to -2, or x such that x is greater than -4, or x such that x is greater than or equal to -4. And so what you have to know what the domain is, but there are some answers that can be eliminated even if you don't know how to do the problem. And I want to, this is a good chance for me to take, for talking about what I call a 2x2 problem. There have been many 2x2 problems already that we've passed, but what is a 2x2 problem? 2x2 problem? Even though there's 4 answer choices, there's 2 sets of 2 details that they're testing. And so when there are 2 sets of 2 details that they're testing, sometimes students get overwhelmed because they're like trying to test both details at the same time, when in fact, there's nothing requiring you to test both details at the same time. You could test both details separately. So what are the 2 details that they're testing here? They're testing whether you have a greater than, or if you have a greater than or equal. But they're also testing if you have a -2 or if you have a -4. And so choice 1 has a greater than, -2. Choice 2 has a greater than or equal to, -2. Choice 3 has a greater than, -4. And choice 4 has a greater than or equal to, -4. And so you can eliminate the choices by identifying 2 separate pieces of incorrect information. Like, for example, I see that there's an open circle, which implies that the endpoint is not included in the graph. And since the endpoint is not included in the graph, and there is no other place where the graph goes lower nor more to the left, that means that the symbol has to be a greater than and not a greater than or equal to, which eliminates choice 2 and choice 4. And I eliminated choice 2 and choice 4, but you, for a different reason, might identify that whether you can or can't use a -2 or a -4. I put a checkbox on both because they both have a greater than. But how to identify which one is correct between choice 2 and choice 4? You also have to know what the domain is. The domain is equal to the set of x coordinates that are part of the graph, are part of the graph of the function. Or that can be plugged in, or have a, let's say, have a valid output value, have a valid output value. So if you notice, if this is about the x coordinates, if the domain is asking what the valid x coordinates are, we are now looking at the valid y coordinates. The -4 comes in because the y coordinates go down to -4 and up, not including -4, but that's the boundary point, but that's part of the range values. The domain is the set of x coordinates that can be plugged in from -2 and to the right. So the ones that have -2 are more correct. Let's do it this one. And the ones that don't have a -2 are not correct. So the only one that has both check boxes is choice 1. So choice 1 is the correct answer. Gee, that's a good. Number 18, which ordered pair is a solution to the equation y minus 1 equals 2 parentheses x plus 1/4? Done. That's the whole problem. Is it 0.75 comma 0? Is it 1.25 comma 4? Is it 2.5 comma negative 6.5? Or is it 4 comma negative 9.5? Literally, you can do this problem in a few different ways, but the main way, plugging in. 99% of students who get this right just literally plug in. That's actually kind of what they're asking. Now, how do I maybe do a quick elimination of some answers? Y minus 1, y equals 1 here. X plus 1/4 is like there. So you have a point there. Let me go now in blue. And now you have a graph that looks like that. Okay, so if you know that this is what the graph basically looks like, just real quick, then you might be able to eliminate some answers. And this one is actually looking somewhat okay. 1.25, depending on who you, I'm sorry, 0.75 comma 0. I just transpose the x's. So this is actually not okay because this is a positive x coordinate with a 0 x-intercept. That's not correct. Let me cross that out. 1.25, because I know it's not correct because we don't have y equals 0 for any positive x coordinate. 1.25 comma 4, maybe that might be correct. And 2.5 comma negative 6.5, that's not below the x-axis, that's incorrect. So just a quick rough graph actually eliminated choice 1, 3, and 4. And so if you actually graph this on the calculator by adding 1 to both sides, you could actually eliminate choice 1, 3, and 4, which is nice. But how do I plug in? Actually, since I would have been plugging in choice 2 anyway, let's actually plug in choice 2. So you get 4 minus 1 equals 2 parentheses 1.25 plus 1/4. And you plug that into the calculator. I'm not going to simulate plugging into the calculator, but this one you get 3 equals 2 parentheses. And when you plug in 1.25 plus 1/4, you get 1.5. And 3 is equal to 2 times 1.5, which is equal to 3. And this is correct. So that means that choice 2 is the correct answer. And we already turned it into a passing problem by eliminating 3 of the 4 choices. PP, passing problem. If you eliminate at least 2 choices, it's a passing problem. Sometimes it feels like it's not worth eliminating any choices. But if you have a 1 in 4 chance of getting it right with a wild guess, that's worse than a 1 in 3 chance of getting it right with a wild guess. And if you eliminate 2 incorrect choices, now you have a 1 in 2 chance of getting it right. That's a passing problem. That's phenomenal. Number 19, Elena's fastest time for the 50-meter dash is 7 seconds. She wants to know how fast this is in inches per minute. Which expression can Elena use for the correct conversion? Is it 7 seconds over 50 meters or 60 seconds times 60 seconds over 1 minute times 1 meter over 39.37 inches? Or is it 7 seconds over 50 meters times 1 minute over 60 seconds times 39.37 inches over 1 meter? Or is it 50 meters over 7 seconds times 60 seconds over 1 minute times 1 meter over 39.37 seconds? Or is it 50 meters over 7 seconds times 60 seconds over a minute times 39.37 inches over 1 meter? So how did I eliminate choices? I want to know inches per minute. And she's running 50-meter dash in 7 seconds. That's 50 meters per 7 seconds. And if she wants to know inches per minute, it takes very little amount of time to run an inch. That's about an inch. That's about an inch right there. And you're talking about how many of those, like in a 50-yard dash, in a 50-meter dash, there's a lot of inches. And now you're talking about not even just 7 seconds. You're imagining she just keeps booking it for another 53 seconds to go a whole minute. In other words, she's running a ton of inches in a minute. So the answer has to be a very big number. So if I just look at which ones are very big numbers, this one's less than 1. This one's less than 1. This one's about 2. No, this one's about 1 and change. So the only one that's big is this one. 100%. I just gave you a way of getting this answer with 100% certainty, even if you didn't know how to do it. Okay, so how can we actually do this question if it was a part 2 question? Um, it's 50 meters over 7 seconds. So now you have to convert these numbers into uh, other units. Now we're going to go to the Regents. The Regents. Good. We're going to scroll all the way to the end. Sorry if the scrolling bothers your eyes. These are the units that they have. It's not that many for the new Algebra 1. They have miles to feet, miles to yards, pounds to ounces, tons to pounds, inches to centimeters, meters to inches, miles to kilometers, kilometers to miles, pounds to kilograms, kilograms to pounds. So there are some units that you kind of have to know. So for example, you have to know how many seconds are in a minute. So there's 60 seconds in 1 minute. Now, how do I know what's right in what? The numerator versus the denominator? I have to write the units so that the seconds cancel. Since these seconds are in the denominator, I have to write 60 seconds over 1 minute. Notice I just multiplied by the fraction equal to 1. 60 seconds over 1 minute is equal to the fraction 1 because 60 seconds and 1 minute are the same number, but with different units, and the seconds cancel. Now I have to convert meters to inches. I have to cancel meters, so that meters is going to be in the denominator and the inches is going to be in the numerator. Why is the meter going to be in the denominator? Because the meters were originally in the numerator. So I have to have meters in the denominator to cancel. And according to this, 1 meter is 39.37 inches. Okay. Let me also take a screenshot of this to put it into the sheet. Good. Oh. Okay. So that's got to cancel. Oh, this all moved. That was weird. Meters and inches. I hope that pasting didn't mess up things above because I was going to convert this into a PDF. So meters and inches, meters and inches, meters and inches, meters and inches. So 1 meter is 39.37 inches. Now for a part 1, I literally just look for the one answer that looks like this, and it turns out to be choice 4. But for a part 2, 3, or 4, I actually multiply these numbers and get a number, and the meters cancels, and then I make sure that I use inches per minute as the correct units. If this has been helpful, I do appreciate the subscribe. Again, I do have over 1,000 subscribers, but I do need also the view time to get the ads that you end up seeing that I don't get paid for a single one of those ads. I do plan on reducing the number of ads that get shown on the video when I eventually get ad revenue. So keep watching if you want to support this channel. Number 20, the table below shows the highest temperatures recorded in August for several years in one town. I do take a quick look at the table, 1990, 91, 92, all the way to 97. And the temperature, 86, 78, 84, 95, 81, 77, 83, 88, and 93. And then the interquartile range of this data is at 7, 10, 11, and 18. So to get the interquartile range, we have to know what that is. But definitely to do this problem, we first have to put the data in increasing order. So, and we have to do that carefully. So I put the numbers that I see, then I put a dot next to it to know I got it. 77 dot 78 dot 81. Luckily, I've done this before, so I know I'm not going to skip any. 84 dot 86 dot 88 dot 93. Let me see if I need to. There we go. 93, comma, dot, and 95. Dot. Now I know I used every single number. Now I see 77 to 95 is 18. 18 is the range. Max minus min is equal to the range, which is equal to 18. But that's not what they're asking for. They're asking for the interquartile range. So I have already eliminated an answer. Now I have a 3 in 4 chance of getting it right. Now, do I see any way of just eliminating any other answers. There are little itty bitty tricks to eliminate some answers, but um, like doing differences of other data, because if you don't happen to know where what the quartiles are, but to really do this problem, you have to know what the quartiles are. So a lot of teachers just talk about Q1 and Q3, but actually you kind of have to know what Q0, Q1, Q2, Q3, and Q4 are. Q1, Q0, Q1, Q2, Q3, Q4. Q0 is the starting number, so this is the min. You could think of this, and I like to think of it as a football game, because a football game has 4 quarters. The starting score is 0-0. It's literally right at the beginning, whereas the final score is the last number. This is the max. So then what is Q2? Q2 is the median. And these are technical terms. Q2, quarter 2, is the median. Why do we not call them Q0, Q2, and Q4? I don't know, but I think it's doing a disservice to you. I do when I'm teaching my classes. So Q0 is the min, Q2 is the median, Q4 is the max. Okay? So now what is Q1? Q1 is the median of the left half of the data not including the median. Okay, so in this case, let's see, Q0, no, the median, let's look at the median. The middle number is right in between here. Q2 is equal to 85. Now, the Q1 is the median of the left half of the data, not including the median, which is in between two numbers. So the median will be right there. And so we got to take the average of these two numbers, 78 plus 81 over 2, which is equal to, on your calculator, 79.5. So the Q1 is equal to 79.5. And Q3 is equal to the median of the right half of the data, not including the median. So why do I think of it as like a football game? This is like the Eagles score at the beginning of the game, 0. The Eagles score at the end of the game, the max. The Eagles score at halftime. And then the Q1 is the Eagles score at exactly quarter 1. And Q3 is the Eagles score at exactly quarter 3. And then at exactly quarter 3, in this case, so this is Q1. And right here, quarter 3, right between these two data points, Q3 is equal to 88 plus 93 over 2, which according to my calculator is 90.5. Do I plug this into my calculator? Yes. And I recommend that you do it too. So Q3 is equal to 90.5. And so what is Q3? What is the interquartile range? Interquartile range is equal to, in letters I, Q, R, and that's equal to Q3 minus Q1, which is equal to 90.5 minus 79.5, which is equal to 11. Very nice. And let's have a little quick snack break to talk about snacks. This is a long video. If you have access to snacks, you can go ahead and get snacks. I'm going to be talking about snacks during the Regents. So if you've heard me say this before, feel free to skip over to question 21. But let's talk about snacks. Snacks that I do recommend for the Regents. Water is a great thing to have. Water is great. The reason I recommend Fairlife, and again, I'm not sponsored by this company, but when you don't say bad things about a company, it's really perfectly fine to talk about the product. The reason I do recommend Fairlife is that it is high in protein, 30 grams of protein. It has a very small amount of carbs, which during a Regents is not great, not bad. A small amount of carbs it might be helpful if you have trouble keeping your carbs low. but we're not being healthful during the Regents. We're being high scoring. And it has only 4 grams of carbs and 2 grams of fat, 2.5 grams of fat. But it's not that much liquid. It's good as a liquid because it'll satisfy your thirst and it'll also make you feel full. And not feeling hungry during a Regents is actually, I think, a really good thing. So having that as a drink is a great idea. Having water as a drink is a great idea. You don't want to overdo it with the number of drinks that you have. Soda is a diuretic. Soda makes you have to use the restroom. So if you drink soda for your caffeine, you may end up having to use the restroom in the middle of a Regents, which means you lose time. Coffee, a lot of people believe that coffee is a diuretic. That is kind of a myth. I think it's completely a myth. I don't know if it's 100%, but a lot of times people think that coffee is a diuretic because it makes you go to the bathroom a lot. But most of the time, that's because a lot of people drink a lot of coffee, not because because the coffee causes you to use the restroom. Coffee and soda have different effects on your body. Um, do I recommend coffee during a Regents? Actually, if you are a professional coffee drinker, meaning you drink 2 to 3 cups of coffee a day, as a young kid, you should probably stop. But if you don't do that, I highly recommend actually not drinking coffee during the Regents. If you want coffee, um, decaf coffee it would actually work wonders. I really slowed down my coffee drinking recently because coffee started to not have much of an effect on me. When I stopped drinking coffee, every once in a while I would have decaf, and decaf does have the same effects that regular coffee has. Why? Because I'm not used to the coffee. But why do I not recommend coffee in the middle of a test? Um, Coffee makes people hungry. Professional coffee drinkers will tell you, no, it doesn't. That's not true. That's because they're professional coffee drinkers. And it's also true even for them. They just don't identify it. What ends up happening is they end up having snacks that are high in carbs and fats. And that's what it does for you. And so it causes your body to go through extreme hunger. And you don't want that in the middle of a region. So if you're gonna drink a caffeinated drink, decaf coffee might be the best, but I actually recommend not necessarily doing it. Now, in terms of food snacks, another one that I would recommend is the pure protein bar. It's really chewy, so it actually makes you eat it very slowly. And this one has 5 grams of fat and 18 grams of carbs and 20 grams of protein. Not the best when you're like dieting, but when you're on in a Regents, you're not dieting, you're high scoring. So this 18 grams of carbs is actually going to give you a little bit of energy to sustain you throughout the Regents. And because it's also high in protein, and it's got a little bit of fat, it's also going to take your hunger away. And because it's chewy, it's going to make it so that you can't eat it that fast. So it's going to sustain your hunger. It's going to sustain your fullness and keep your hunger away. Okay, that's my conversation about snacks. At this point, I'm going to move on to number 21, which I have to reduce its size because it's way too big. There we go. Number 21, the function f of x equals x squared is multiplied by k, where k is less than -1. Which graph could represent g of x equals k times f of x? Is it choice 1, which is an upward-facing parabola, thicker? Choice 2, which is a downward-facing parabola, thicker? Choice 3, which is a thin upward-facing parabola? Or choice 4, which is a thin downward-facing parabola? So can you do this problem by calculator? Yes. So I don't know. Fixed student mean doesn't know. Like I actually happen to know the answer right away. I also happen to know the exact equations for each of these right away. But you might not. But what would I do if I needed to use my calculator to eliminate an answer? I know that k is less than -1. How about try k equals -2, and then graph. So it's g of x equals kx squared. So graph uh, y equals -2x squared. And see which one looks like y equals -2x squared. This one will look like -2x squared, but since the scaling on your calculator won't be exactly square, this one might look like -2x squared. So I'll put 2 check boxes here because I like this one. Um, I like number 4 more than I like number 2. But choice 1 is upward facing. Negative number will flip the parabola to be a downward facing parabola, downward opening parabola. And choice 3 is also an upward opening parabola. The answer has to be a downward opening parabola. we turned by graphing, but we've turned this into a passing problem. Now it happens to be that one of these answers, specifically choice 4, does match y equals negative 2x squared. So it kind of has to be this one. But that said, we have to know what the effects of this value of k are for the purposes of the part 2s, 3s, and 4s, and for the purposes of knowing our stuff. So if k is negative, that means that the parabola will be flipped vertically. So it'll be downward facing. Okay. So that does eliminate choice 1 and choice 3 for sure without even graphing. And also, if negative infinity is less than k is less than 1, or in other words, negative 1, or in other words, if the absolute value of k is greater than 1, that implies that the parabola is stretched vertically. And if we graph y equals x squared, we get a parabola that looks like this. Get a parabola that looks like that. And if we flip that, we get a parabola that looks like this. Arrow, arrow. So this one is not stretched vertically. This one is squished vertically. So that makes that one wrong. And this one is stretched vertically. And it's also flipped vertically. So that one is correct. Okay. Okay. Number 22. Which graph is the solution to the inequality 6.4 minus 4x is greater than or equal to negative 2.8? Now, before I verbally describe what each of these answers state, I got to assume that I'm a student who doesn't know necessarily what these things state. But I do remember that shading a region means that it's part of the solution set, and not shading a region means that it's not part of the solution set. So I actually can eliminate all of the incorrect answers by plugging in test points. Because this is a 2x2 problem. In other words, I noticed that choice 1 has an open circle at 2.3. Choice 2 has an closed circle, shaded circle, which means it's part of the solution at 2.3. Choice 3 has an open circle at 2.3, but it's pointing to the left, whereas choice 1 and 2 are pointing to the right. And choice 4 has a closed circle at 2.3, and it's shaded to the left. So the 2x2 is, do we have an open circle or a closed circle at 2.3? And are we shading to the left or to the right? So actually test points of 0 and 2.3 will confirm which answer is correct with 100%. This would do 100%. Okay? So, for example, if I plug in 0, I get, if x equals 0, I get that 6.4 minus 0 is greater than or equal to negative 2.8. So is 6.4 is that greater than or equal to negative 2.8? Yes. So 0 is in the solution set. 0 is in the solution set. That eliminates choice 1, and it eliminates choice 2. So we've got a passing problem. Passing problem. Because we've eliminated 2 choices. The moment we eliminate 2 choices, we've got a passing problem. Now, the other thing is, if you are the kind of student who happens to remember, oh, greater than or equal means that we fill in the circle. This one's not filled in. That means that choice 3 is eliminated. You actually have already done the problem. It's a 2 by 2 problem. How do we do this if this were a part 2 problem, though? Because this is a perfectly valid part 2 problem. This would mean, instead of being like problem 25, this might be like problem 29 or 30. Let's do the problem fully. We got, so the equation is, the inequality is 6.4 minus 4x is greater than or equal to negative 2.8. What I would do first is I would subtract the 6.4, and I would use my calculator to confirm negative 4x is greater than or equal to, I would confirm that this subtraction is equal to negative 9.2. And then where students get messed up here is when they divide by the negative 4, divide by the negative 4 is this inequality symbol. If I divide by negative 4, I divide by a negative number. That implies that the inequality symbol switches direction. So I switch the order of this inequality symbol from greater than or equal to less than or equal to, and I get x is less than or equal to positive 2.3. And so now to talk about what these symbols meant. The open circle means either greater than or less than, like choice 1 and choice 3. And the closed circle means either greater than or equal to or less than or equal to, like in choice 2 and 4. So choice 2 is shading to the right, which means x is greater than or equal to 2.3, and choice 4 is shading to the left, which means that x is less than or equal to 2.3. So choice 4 is the correct answer. Number 23. The number of fish in a pond is 8 more than the number of frogs. The total number of fish and frogs in the pond is at least 20. If x represents the number of frogs, which inequality can be used to represent the situation? Is it x plus 8x is greater than or equal to 20, or 2x plus 8 is greater than or equal to 20, or x plus 8x is less than or equal to 20, or 2x plus 8 is less than or equal to 20? This is actually another 2 by 2 problem, because it's asking, is it x plus 8x or is it 2x plus 8? That's one set. Well, that's one set of choices, and the other one is it greater than or equal to 20 or less than or equal to 20? So if you could eliminate this by identifying 2 different facts, you can answer the question. So in this case, I see that the number of fish in the pond is 8 more than plus 8 the number of frogs. Now I have an equation. It's a word equation, but it's an equation. So if I bring in a variable into the problem, I can get an equation. Number of fish is equal to number of frogs plus 8. And it said that the total number of fish and the number of frogs in a pond is at least 20. So the number of fish plus the number of frogs is at least 20. And this is where students get stuck. At least 20, you have to know what that means. At least 20 means it could be 20, but it could also be more, 21 or 22 or 23. So the number of fish plus the number of frogs has to be greater than or equal to 20. And now that actually eliminates the ones that have less than or equal to. Passing problem. Passing problem. So we still don't have an x in there. This one says if x represents the number of frogs, so x is the number of frogs, x is the number of frogs, that means that the number of fish is x plus 8. So I have x plus 8 plus the number of frogs is x, that's greater than or equal to 20. I have an inequality with x in it. And then which inequality can be used to represent the situation? I have x plus 8 plus x is greater than or equal to 20. This one, number one, has x plus 8 times x, not x plus 8 plus x. So that one is likely incorrect. Fake student me might not be sure. Real teacher me is already 100% sure that one is not correct. But by the commutative property, I could add the two x's, and I get x plus 8 is greater than or equal to 20. That's an 8. And x plus 8 is the same thing as 2x plus 8 is greater than or equal to 20. So 2x plus 8 is greater than or equal to 20 is choice 2. And at this point, we can start to celebrate having a perfect part one. We are about to do that. Then we need to shrink the size of this problem. With this problem, we will have a perfect part one and 48 points on this Regents, which is super. That's actually quite a bit more than passing. But I do want to point something out here. Passing 29 points and we get a 65, but let's see what 48 points is. 48 points, despite the fact that we got a ton more points, that's only a 75. So if you want an 80 or more, you have to get points on the part twos, guaranteed. If you literally only focus on the part one, you're already capping your score at 75. So here, I mean, I always give 1,000 reasons why not focusing on just the part ones is a bad idea. But for teachers, here it is. And for students who really say, oh, I'm just going to focus on the part ones, here it is. If you focus on only the part ones, you literally are not capping your score at 100. You're capping your score at a 75. So you're working at between a 0 and a 75, and you're trying to get at least a 65. Your perfect score in quotation marks is a 75. You're 10 points away from not passing. So, and every time you get a few more points off on your multiple choice, you're getting more and more closer and closer to not passing. And then you're going to see that a lot of the stuff that we do actually can eke out a ton of points on the uh, part twos, threes, and fours. Okay. All right. Um, so number 24, which graph below represents a function that is always decreasing over the interval -3 to 3, always decreasing. So it's always on the way down from -3 to 3. So here's -3 to 3. And we do have to know that we're moving in the horizontal direction to the right. That's a minimum condition to being able to understand this problem, to the right. So the question is, which one of these is going downward from -3 to 3? It's funny because even if you didn't know that, like you didn't know which direction to go, you can actually eliminate choice 1 and choice 3 because both of them are going in the same direction. So it can't be that two different choices are both correct in a multiple choice test. So because choice 1 and choice 3 would both be correct if you interpreted both of those as decreasing, they're both incorrect. That's great. We just turned this into a passing problem because a multiple choice question can't have two answers. And then between choice 2 and choice 4, the one that makes the most sense, I think, is choice 4. I don't think choice 2 makes the most sense. So what does it mean to be increasing? As you're moving to the right, we have to move to the right. Decreasing means that y is getting smaller. So as you move in this direction, y is getting bigger. Here, y is getting bigger. Or using their word, increasing. And here, as we're moving to the right again, here y is increasing. It's from here to here. X equals -3 to x equals 3. Here, y is increasing. And here, y is decreasing. So this is another reason some students would get it wrong. They said always decreasing, always decreasing. Choice 2 can't be the answer either. And this one, from x equals -3 to x equals 3, y is decreasing. Y is getting smaller. So the answer is choice 4. And we have a perfect multiple choice test and a 48 out of 82, but only just a 75 so far on this test. But if your goal was to get a 75, we got that 75. But we do want to eke out more points on the part twos. And we're going to see that that's actually super necessary. It's super necessary to be guaranteeing that we're going to get the grade that we want. Um, it's going to be necessary to do the problems in the part 2s, 3s, and 4s at least as best as we can to get the grades that we want. Because again, if your goal is to get an 80, we just proved you can't get an 80 with focusing on just the part 1s. Your literal perfect part 1 max grade is 75. And of course, a few points missing here and there, accidental missing negative signs, accidental fraction bars, accidental parentheses missing, misreading a word can get you easily below a 65. Now, this part says there's a couple of things. Diagrams are not necessarily drawn to scale. I have my students, and you're going to see right on question 25, almost definitely drawn to scale. And the second piece, um, you have to show necessary steps, formulas, and substitutions, diagrams, graphs, and charts, etc., to get full credit. But and utilize the information provided for each question. I also have students to write the word all, because there aren't any problems where they leave unnecessary, where they put in real, true, unnecessary information in the problem. We did a disservice to fourth and fifth graders by teaching them that all problems that do that. In fact, almost no problems ever do that. Almost every detail is relevant. And when I say every detail, a problem doesn't matter. It doesn't really matter mathematically whether we're talking about cantaloupes or cars or carrots. It doesn't matter what the object is. It matters how those objects are related to the numbers. And that, in that way, they're almost never going to put unnecessary information. In fact, even when they do put information that is not needed, it's often the case that there are ways of doing the problem with that information. So they really rarely do put things that aren't needed at all. So if you're stuck on a problem ever, the first thing you should do is to look for, is there anything that I didn't use yet? And read the problem carefully from beginning to end, because you will likely find something. And here's the last part that I want to say before actually doing the problems. A correct answer with no work will receive only 1 credit. And you might say only 1 credit. Well, 1 is greater than 0. So if you actually don't know how to do the problem on paper, but you do know how to do the problem on the calculator, then do the problem on the calculator, put the answer in, you get a point. A point is a half a multiple choice question. A point raises your grade, guaranteed. So you should do every single question if you know how to do it on the calculator. Now, here's where the almost definitely drawn to scale matters here. This problem has a graph in it. Graphs actually have to be drawn to scale. It's an absolute requirement of math that graphs be drawn to scale. Not drawing a graph to scale is like purposely putting in typos in your test. They're never going to purposely misspell the word graph. They're also never going to purposely make a graph not drawn to scale. It's actually illegal to make a graph not drawn to scale. That's the nature of it. So every diagram, assume that a diagram is drawn to scale unless there's a good reason to think that it's not. There's actually reason to think that this has to be drawn to scale because it is a graph. Okay, so number 25. The graph below models Sally's drive to the store. And I do look quick. Speed, miles per hour, 0 to 50, goes up, sideways, and then down. Time, 0 to 10, and then some. It says state the interval when Sally is traveling at a constant speed. So when I'm doing that problem, and then the next part says to explain your reasoning. When I'm doing this problem, I'm thinking to look at I need to look at the y-axis. I have to. I will get this question wrong if I don't look at the y-axis. The y-axis is speed. So if they want to know if it's at a constant speed, that means that the graph of the speed is horizontal. Why I have to look at the y-axis is that they didn't have to give me the graph of the speed. They could have given me the graph of the position or the graph of the acceleration. But they gave me the graph of the speed. When is Sally traveling at a constant speed? When the graph is horizontal. And so the answer to this question is from 5 to 9. I could also say 5 less than or equal to t less than or equal to 9. I could also say 5 to 9. I mean, they're pretty permissive, but this is the way I prefer to give it. Okay, and to explain my reasoning, um, uh, the interval, from 5 to 9 is where the speed is constant, 35 miles per hour. So the interval 5 to 9 is where the speed is a constant, um, 35 miles per hour. Full credit. Number 26, graph the function f of x equals x squared plus 4x plus 3, and then state the equation of the axis of symmetry. This is a great example of a problem that can be done on a calculator despite it being a part 2. I've seen students get this question wrong, and in fact, when I first, let me deactivate these because I'm going to use the graph. I don't want to, I like not deleting anything from the y's equals unless I kind of have to. I'm going to put y equals x squared plus 4x plus 3. When I was first doing this problem, my first graph was actually kind of incorrect. I was doing a quick thing, then I did the second part, and then I went and fixed the graph. But the fact is that if you actually graph this, you could actually see what the graph is supposed to look like. And then you might actually graph an accurate answer. Now, another thing that I recommend is going to the calculator table and getting some y values. Okay. Now, you should know the rules for whether you need to label your axes with numbers is that if your numbers skip count by exactly 1, you don't have to put numbers. But if you want your axes to skip count by more than 1, you have to put numbers. So I'm going to graph the point. Let's see. It only goes up to the left -5, to the right 5, up 5, down -5. So if I go to -4, 3, -3, 0, -2, -1, -1, 0, 1, 0, 3, and then 1, 8 above the graph. If you graph this way, there's 2 minimum requirements that get you the full credit on the graph. One minimum requirement is that you go all the way to the end of the graph. And the second minimum requirement is that you put arrows at the end if arrows at the end is actually appropriate. In this case, both of those conditions, I recommend to my students doing both of those things so they get accustomed to doing both. So arrow, then down. The second thing is you can't draw this graph with a ruler because it's a curvy graph. If the line is straight, you have to use a ruler. And if the curve is not straight, you are not allowed to use a ruler. Notice that my parabola is a little bit wiggly. They expect that. They expect that. You can't draw perfectly curvy parabolas as software does it with your pen. Okay, so do feel free to just draw freehand, and in fact, you're required to draw freehand if you're drawing a curve that's not straight. Okay, and then I have to state the equation of the axis of symmetry. Okay, so state the equation of the axis of symmetry. They actually asked me to state it, so since I actually can just see that the axis of symmetry is vertically at y equals -2, I could just say y equals -2. And that would be full, I'm sorry, x equals -2. Since I know that it's at x equals -2, I could just state x equals -2. And they didn't say determinant state, but since they often do state determinant state, I'm sorry, I did it twice. If they just said state, you could just say x equals -2. But if they say determinant state, you actually have to do the algebra. You could say x equals -b over 2a, which is equal to -4 over 2 times 1, which is equal to -4 over 2, which is equal to 2. So x equals 2 is the -2. Lost my negative sign. See, twice in a row. In one video, I lost the negative sign. So if I lose negative signs, it means that you should very much watch out for negative signs lost. X equals -2. Full credit. Number 27, the function f of x is shown in the table below. And I do take a quick look. X equals 0.32615 and m, and then f of x equals 62758,439. And then it says to state an appropriate value of m in the table so that f of x remains constant, remains a function. And what does a function have to satisfy? So each x value or really each domain value maps to a unique y value. No, not to a unique. That's not the correct wording. Only one y value. Only one y value. Each x coordinate maps to only one y value or only one range value. In fact, that's the explanation for my reasoning. So this is me taking notes so that you see it, but really that's the explanation that I would write. So any x coordinate except one that's been used already would be a valid answer here. How about m equals 10? That's what I put on my paper too, m equals 10. You could put literally any number except 0, 3, 2, 6, 1, 5, or 4. Any number except 0, 3, 2, 6, 1, 5, or 4. 7, 8, pi, anything you want. Anything except 0, 3, 2, 6, 1, 5, or 4. And the reason is each x coordinate maps to only one range value. Each domain value maps to only one range value. And what I said here is functions map input coordinates to only one output coordinate. Number 28, solve x squared plus 8x equals 33 for x by completing the square. And they actually already did some of the work. So I want to show you the procedure for completing the square. And so the first thing is you get x squared plus bx is equal to a constant. However you do. And that's already done for us, which is great. 2, right? b over 2 equals, and b over 2 parentheses squared equals. So what does b equal? B equals the coefficient of x, so b equals 8. B over 2 equals 8 over 2, which is equal to 4. And b over 2 squared is equal to 4 squared, which is equal to 16. Okay? Step 3, gonna add b over 2 squared to both sides. So I'm gonna plus 16, and I get that x squared plus 8x plus 16. Let me erase that underline because it looks like a negative sign there. Is equal to 16 plus 33, which is equal to 49. Okay? And then step 4, and you don't have to write your steps, but I need you to understand. Step 4 is to factor the left as x plus b over 2 parentheses squared. So x plus b over 2 squared. So x plus b over 2 is 4. 4 squared equals 49. And then step 5 is to solve via the inverse operation method. So what does that mean? It means to undo all the operations one at a time using the inverse operation. Okay. So I'm gonna rewrite the equation. I got x plus 4 squared equals 49. Let's solve this in green. Take the square root of both sides, and I got x plus 4 equals, this is where students mess up. When you take the square root of both sides, you gotta remember to put a plus or minus, radical 49 is 7. And then subtract 4 from both sides. And you get that x is equal to negative 4 plus or minus 7. And this is a perfectly valid solution, then they'll accept this. But if you wanted to separate this into two different answers, you get x is equal to negative 4 plus 7, or x equals negative 4 minus 7. So x is equal to 3 or negative 11. And those are my answers. Full credit. Could you do this on paper or on the calculator? You actually could do that on the calculator. Get your points by graphing. Graph that. And then graph this, meaning y is equal to 33. You'll have to zoom out, and find the x coordinates of the intersection points. So if you actually said that, and if you actually did that and you just wrote down 3 and negative 11, you'd get a point. And in fact, if you said a lot of that already, sometimes if you show some of that somehow on paper, you might get 2 points. But since they specifically said completing the square, they won't give you full credit for that. But again, just stating 3 and negative 11 is a point, okay? Number 29. If f of x equals negative 3x minus 5 over 2, algebraically determine the value of x when f of x is equal to negative 22. So again, so to get a point, you could put this y equals, and then scroll to y equals negative 22, and that will give you x equals 13. That's a point. It's a point, but it's also a check of your answer. So if you happen to know how to do this one algebraically, then this checks your answer. F of x equals negative 22. So how to do this? We do negative 22 equals negative 3x minus 5 all over 2. Multiply both sides by 2. Multiply both sides by 2. We get that negative 44 equals negative 3x minus 5 plus 5 plus 5. I know some of you don't know how to add negative numbers and positive numbers. Don't be ashamed of using your calculator. Just use your calculator. You deserve your points. Yeah, there was a time to learn how to add and subtract positive and negative numbers, but not the Regents is not the time to sit there and guess. The Regents is the time to be humble and put it in your calculator. Look, I'll do it one time just to simulate it, and then you know that most of the time I haven't been doing that. You put negative 44 plus 5. It'll tell you, I think it's plus 5. I think it's negative 39, and in fact it is. Negative 39 equals negative 3x. Same thing, I'm going to divide by negative 3. I know you should know how to multiply and divide by negative numbers, but if you put that in the calculator, negative 39 divided by negative 3, you get x equals positive 13. And there's our full credit 2-point answer. They did say algebraic, so it does have to be an algebraic method. And at this point, with this problem, number 30, we can celebrate getting an 80. Finally, on this Regents. Notice that we did the multiple choice all correctly and got a 75. It took us problem 25, 26, 27, 28, 29, 30, all perfectly correct to get 5 more points. So getting an 80 is not easy. So the lesson here is you have to do as much as humanly possible in the part 2s, 3s, and 4s to get those really high grades that look good on your transcript. Okay? So now with number 30, we could celebrate getting our 80. Rationalize the denominator of the fraction below. Express your solution in simplest form. I know a lot of old heads were hating the fact that students didn't know how to rationalize denominators, so now they brought it back into the standards. How do you rationalize the denominator? Multiply by the conjugate of the denominator, or if it's just a plain radical, you could just multiply by the radical, radical 2, and the numerator is equal to 4 radical 2. The denominator is equal to radical 2 times radical 2. If you don't know what radical 2 times radical 2 is, be humble. Use your calculator. It's equal to 2. And then 4 divided by 2, divide by 2, divide by 2. 2 divided by 2 is 1. And 4 divided by 2 is 2. When you divide a factor in the numerator, you only divide one of the factors of the factor in the numerator. So the 4 divided by 2 is 2, and so this answer is equal to 2 radical 2. You could check your answer by doing 4 divided by radical 2 in the calculator, and if you suspect that the answer should be something times radical 2, then you could actually get your point. You can get your point, put 4 over radical 2 in the calculator, get a decimal, and then put in 1 radical 2 and 2 radical 2, 2 radical 2 in the calculator, and that's the correct answer. And then you just write 2 radical 2. So this test, by bringing back some of the things that the old heads used to like to be on Regents, they actually also made it so that you can actually eke out individual points by just plugging into your calculator and getting the correct answer. And that's our 80. We got an 80. Now we're on the part 3s, which are the 4-point questions. A lot of students are like, okay, so I'm going to focus on the part 1s and only the part 2s because the part 3s are harder. The part 4s are harder, except the part 3s are worth more points and the part 4s are worth 3 times as many points. So the thing is that difficulty, and the moment they made difficulty and point value in proportion, they actually made it so you kind of have to focus on the part 3s and 4s also. So by saying I'm only going to focus on the part 2s, you're actually saying, if you're very logical, you're actually also saying I'm also going to focus on the part 3s and 4s because you have to. Double the difficulty, double the value, they're equivalent to a part 2. They really are. So same thing as before. Diagrams are almost definitely drawn to scale, and then numerical answers will receive only 1 credit. That's super duper, and clearly indicate all necessary steps. Okay, number 31. Let me flip to number 31. Number 31, Alex has $1.70 in nickels and dimes on his desk. There were 25 coins in all. Write a system of equations that could be used to determine both the number of nickels and the number of dimes, D, that Alex had. And the second half of it is use your system of equations to algebraically determine both the number of nickels and the number of dimes. Here's the thing. If you happen to know that a nickel, this is an unfortunate cultural thing that you have to know. A nickel is 5 cents and a dime is 10 cents. It's a cultural thing. It's a US thing. You have to know that. But now that we know that, if you happen to know that a nickel's 5 cents and a dime is 10 cents, you could actually just manually work this problem out to see how many nickels and dimes you have. Like if you have all 25 are dimes, you have $2.50. That's too much. So if you reduce the number of nickels to like 20, I'm sorry, if you reduce the number of dimes to 20, you still have $2. So if you reduce the number of dimes to 15, now you have $1.50. Now you need how many nickels to get $1.70? 4 more, and that's only 19 coins. So you actually have to reduce the number of nickels again, and you keep doing trial and error until you get the correct number of nickels and the number of dimes. So the number of dimes already we've confirmed has to be greater than 15. Has to be less than 15. The number of dimes has to be less than 15. And the number of nickels has to be greater than 4. And you keep trying numbers until you get the answer and plug it into the last part. So you get your points point by trial and error. So you get 1 point. And remember, 1 point is 1/2 of a multiple choice question. So should you focus on the part 2s, 3s, and 4s? You can get your points in many situations. Yes, you should. So how do I do this problem? I teach students to do this in word equations. So if we we have to use their letters. They gave us letters, but if they didn't give us letters, we use let statements. Let n equal number of nickels, and let d equal the number of dimes. Okay, now they said that there's 25 coins in all. Word equation would say that the number of nickels plus the number of dimes is equal to 25. And so if I write those letters in an equation, n plus d is equal to 25, I got a point. So now I got a point, and if I did trial and error and I get a value for the second half, that's 2 points. On a part 3 question, that's half the points already. Then the second word equation, let's see, I have $1.70 in nickels and dimes. So now that's talking about the value of the nickels. So the value of the nickels plus the value of the dimes is equal to $1.70. Okay, and so I'm going to write this one in red. The value of the nickels. So if 1 nickel is 5 cents, 2 nickels is 2 times. I don't care that it's 10 cents. I actually don't care that 2 nickels is worth 10 cents. I care that it's 2 times 0.5 cents. 3 nickels is 3 times times 5 cents. 4 nickels is 4 times 5 cents. So the value of the nickel is the value of n nickels is n times 0.05. And the value of the dimes is, well, 1 dime is 10 cents. 2 dimes, I don't care that it's 20 cents. 2 dimes is 2 times 10 cents. Dimes is 3 times 10 cents. 4 dimes is worth 4 times 10 cents. So d dimes is worth d times 10 cents. So plus d times 0.10. That's equal to 170. Do I need my dollar sign in the equation? I actually am not required to have it. And some students will write it this way, 0.05n plus 0.10d is equal to 1.70. But the way I wrote it the first time is actually perfectly valid for 2 points. Now I got a point for the first equation, a point for the second equation. And if I get my trial and error and I get my answer for the third part, that's 3 points on a 4-point question. But now it says to use your system of equations to algebraically determine both the number of nickels and the number of dimes. And so I'm going to do some algebra here. I have to do it algebraically. They're requiring it. So to get a full credit. So I'm going to do, let's do this in red, the n plus d. I'm going to do this by substitution. N plus d is equal to 25. I'm going to subtract d, and I get that n is equal to 25 minus d. And I'm going to plug n equals 25 minus d into the second equation. So I got 0.05n plus 0.10d is equal to 1.70. And I'm going to replace the n with a 25 minus d. So I got 0.05 parentheses 25 minus d plus 0.10d is equal to 1.70. I'm going to stop looking at my work because that'll probably mess me up more than just doing it directly. But I'll be able to erase if I make a mistake. 0.05 times 25, let your calculator be the one that does that. 25 nickels is $1.25, so 1.25 minus 0.05d plus 0.10d is equal to 1.70. Subtract 1.25. I don't like the 7. I don't like the 7, and I erased it to rewrite it again. Not because I'm being pedantic or anal for a test. I subtracted, I erased it and rewrote it because a lot of students will like write over a number and swear that they wrote it over the number enough times that now they can tell what they meant, and they get the question wrong because 2 seconds later they forget. It happens all the time, and if you're a struggling student, it probably happens to you. So on the right side, 1.7 minus 0.25, let your calculator answer that that's 0.45. And minus 0.05 plus 0.10, let your calculator answer that that's positive 0.05. Then these are being multiplied, so I have to divide by 0.05, divide by 0.05, and I get that d is equal to, let your calculator do that 0.45 divided by 0.05 is equal to a solid 9. And if you did your guessing and checking, you would have found that d is 9. Now let me go a little bit to the right here to get my value of n. I will get my value of n by going to my original n plus d equals 25. So n plus 9 is equal to 25. Subtract the 9, I get that n is equal to 16. And that's all they asked for. I circle that. I circle that. And I can check my answer by just checking that this works. 16 nickels. Well, let's try 9 dimes. 9 dimes is 90 cents. So now I need another 80 cents to get to $1.70. 80 cents is 16 nickels. Okay, so there we go. Number 32. The table below shows the average heart rate X and calories burned Y for 7 men on an Olympic rowing team during a 1-hour class. I do take a quick look at the table. Average heart rate 135, 147, 150, 144, 146, 153, 143. And the calories burned, whole bunch of numbers. I just look at it real quick. I see that they're all scrambled a certain amount. And I write a linear regression equation that models these data rounding to all values to the nearest 10th, and to state the correlation coefficient rounded to the nearest 10th, and state what the correlation coefficient means, suggest in terms of the linear fit of these data. The Regents will always ask this. I was wondering whether the new Regents will keep asking this question, and clearly the answer is yes. This question is essentially identical to the ones that they were asking on the previous Regents. So now you know that they're going to maintain this question on the Regents. This is not anything except a calculator question. So do you have to know how to do this question? Yeah. If you want to know how to get your point, this is going to be cheap. This is going to be cheap to how to get your point. If you have no clue how to do this question, you write the word strong here. It's like a 99% chance, not 99%, but like a 90% chance that for what the correlation coefficient suggests, that you'll get a point there. Get your point. Not a fan of that because it's not guaranteed, but it's almost always the case. So, but let's talk about what to do. How do you do this question? And you really do have to know how to do it. Press the stat button, go to edit the list. I'm going to clear these. Okay. Now, I recommend to students typing these numbers and then checking that you typed it correctly. This is not the time to not check if you typed it correctly, but if you actually type and check, it kind of overloads your short-term memory. So I type 135. I'm not even checking. 147. Enter. 150. Enter. 144. Enter. 146. Enter. 153. Enter. 143. Enter. And now I check if I got this, if I typed it correct. And I have to. 143, 153, 146, 144, 150, 147, 135. Perfect. Now the second list, the Y coordinates, calories burned. So, again, I'm going to do the same thing. 725, 812 without looking to see if I typed it correctly. 866, 761, enter. 825, enter. 863, enter. And then 737, enter. And now I have to check if I typed it correctly. 737, 863, 825, 761, 866, 812, 725. Type them all correctly. I have to do that because if you typed even one of them incorrectly, you're just going to get a wrong answer for every single question. So I've seen students who know how to do this question and still don't get their points because they didn't bother to just check that they typed it correctly. But also take my advice, type them first and then check so you're not overloading your short-term memory. So just to review again, how did I do that? Step 1, press stat, edit, clear the lists if you need to, and then type the numbers in. The X coordinates go in the first list, the Y coordinates go in the second list. Now, there's a second thing that you have to know how to do. If you press your mode, some of you have diagnostics off and on as an option in your mode. And as I do, press enter. Some of you don't, but you have to know this piece because don't ask why, because I don't know the answer. And I think it was a bad, weird, or maybe good decision. Maybe it was a good decision. Sometimes the calculators got upgraded software, but they didn't change the name of the software or the calculator. So there's more than one TI-84 plus C Silver Edition softwares. Some of them have that as a mode, some of them don't. So this part, you don't know which calculator you're going to get. So this you have to know how to get the diagnostics on. The catalog in blue has every function on the calculator. So if you press the blue second button, go catalog. Scroll down, 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 down. Keep scrolling down to D. Keep scrolling down, keep scrolling down, keep scrolling down to diagnostics on. Press enter, enter. Now your diagnostics are on. So that's the second step, making sure your diagnostics are on. Now the third step, we're going to do the linear regression, AX plus B, stat, calc for calculate, lin reg, AX plus B. Notice this says LIN reg, AX plus B. The slope is A, the y-intercept is B, lin reg, AX plus B. X list is list 1. Your Y list is your list 2. We didn't use a frequency list, so let's not worry about that. To store the regression equation, I actually like to do that. So I'm going to show you how to do it since it's a video. I could show you one time. Press the vars button for variables. Y variables. Function is choice 1. And I don't remember if I used function 5 as a regression. As any equation at all, so I'm going to choose y5, just y5. You could choose any of the y's and press enter, calculate. Now it's going to give me my equation, but it doesn't write down the equation. It gives me the coefficients. Okay, so what does this say? If you say y equals ax plus b, and then you write the whole a and then you write the whole b, but don't round, you get a point. If you do round and do it that way, you actually get 2 points. But I actually recommend writing the equation. Why do I recommend writing the equation? Because you're required to use the variables that they use. They happen to use x and y. Sometimes they don't use x and y. They might use like g and t or f and t, and you have to use their letters. So the equation is, and this is a second thing to fix muscle memory. I actually recommend writing all the decimals and then rounding. Okay, so y equals 9.117774566x plus negative 527.5563584, and then go into the look for the rounded that they want nearest tenth. And so y is equal to 9.1x minus 527.55. The second 5 causes us to round the first 5 to a 6. 2 points on this test. Now state the correlation coefficient. The reason, let me put this down here. The reason we had to turn diagnostics on is that that's where your R and R squared come from. Those are your diagnostic numbers. So R here is equal to 0.90223833419. Then I go again, nearest tenth, R equals 0.9. That's the third point. And remember I said that 99% of the time, or it's more like 90, but close to 99% of the time, if you just write the word strong at the end, that's a point. Because state what the correlation coefficient suggests about the linear fit of the data. The word strong is they accept that. So, but how do we know what the answer is? So if absolute value of R is between 0.7 and 1, that implies a strong correlation. And what does a strong correlation mean? It means that the data fits this linear equation extremely well. If you had like an R between like negative 0.2 and positive 0.2, that would be no, that usually actually we say no correlation because it's such a small number. And if you had an R between like 0.4 and 0.7 in absolute value, we say moderate correlation. But yeah, if the R is between 0.7 and 1, strong correlation. You could have also said strong positive correlation. Where it's the positive because R is greater than 0. If R was less than 0, you'd have to say strong negative. Like if R was like negative 0.9, you'd have to say strong negative. But actually, just the word strong is perfectly valid. Get your point. Number 33, use the quadratic formula to solve x equals, x squared plus 4x minus 3 equals 0. Express your solution in simplest radical form. I'm not sure if I know a great way to get your points with knowing nothing. That tends to be impossible, nearly impossible, as you would suspect. That getting 1 point with knowing nothing is nearly impossible. But I do know that the axis of symmetry is equal to x is equal to negative b over 2a, which is equal to negative 4 over 2 times 1, which is equal to negative 4 over 2, which is equal to negative 2. So the answer is going to be equal to negative 2 plus or minus a radical. So if you actually uh, cheaply guess at the answer, like for example, so if you get your points in the following, graph y equals x squared plus 4x minus 3, okay? Get the root as a decimal, and then get roots as a decimal, find which number you could put in the radical gives that answer. And then you state that answer, just write that answer. Then you get your points. And I think 7 does it. So that's how you can get a point, even on a question you don't know how to do. But ideally, you would know how to do this with the quadratic formula. I'm afraid of pasting the quadratic formula since I did a bunch of writing over here. It might mess up all the writing. I might do it anyway. I just might paste it above. So if we go to our Regents again, go to the formula sheet. The formula sheet actually has the quadratic formula, which is nice. Okay. So I'm going to zoom in to the quadratic formula here. Do I wish you just knew the quadratic formula? Of course I do. But because it's such a popular formula. Like you can come across adults today who don't remember algebra at all, but remember the quadratic formula. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you plug in the numbers a equals negative 1, and b equals 4, and c equals negative 3, okay? Plug in those numbers, well, you get x equals negative 4 plus or minus the square root of b is 4 squared minus 4 times a is negative 1 times c is negative 3. And that's equal to, sorry, that's an error. I made an error, didn't I? Positive 1. A is 1. And 2a is 2 times 1. I realized I made the error when I was going to write 2 times 1 and I had a negative 1 here. I also made an error because I realized I already knew what the answer was going to be. So that said, now I'm one of the rare cases that I actually gain negative signs when I make errors. So that's something I watch out for. Most students don't gain negative signs, but actually most students do lose negative signs. So keep an eye on those negative signs. And I get x equals negative 4 plus or minus the square root. And you could plug this into the calculator, 16 plus 12. Don't be ashamed that you have to do negative 4 times 1 times negative 3 in the calculator to make sure that it is a positive 12, because you can lose your points if you don't. Divide by 2 times 2 is 1. That's equal to negative 4 plus or minus the square root of 28 over 2 over 2 all over 2, okay, which is equal to negative 4 plus or minus radical 4 radical 7. So 28 factors as perfect square 4 and factor pair is 7. And so I factor out a perfect square because, or the greatest perfect square that I could find, so that I could simplify the radical because it's part of the requirements over 2. And so this is equal to negative 4 plus or minus 2 rad 7 over 2. I didn't expect them to accept this answer as is because it can be simplified a little further. But the reason they accepted it is because they said in simplest radical form. And the radical is simplified as much as possible. But if you also wanted to divide by 2, you can get the negative 4 has to be divided by 2, so negative 2 plus or minus the 2 divided by 2 is 1, radical 7. And either one of these answers would be worth full points. At this point, with this problem, number 34, this problem will give us the 90 on the Regents and a perfect part 3, which is great. But we do need this problem to get the 90, okay? If we look at the score, to get a 90, we need 74 out of 82 points. So 8 points away raw score from a perfect grade is also 10 points away from the scaled score. So we need 2 points out of this one to get a 90. So number 34, solve the following system of equations algebraically for all values of x and y. Y equals x squared minus 7x plus 12, and y equals 2x minus 6. Big thing where students lose points in this problem, they think they can get x and don't have to get y. But since this problem stated x and y, you have to get x and y. If they said like f of x equals and g of x equals, then the answer is just the value of x. But because they said y equals and y equals, now they're the same variable. Now you have to get both x and y. How am I going to do this problem? I'm going to take this, since they already solved for y equals 2x minus 6, I'm going to substitute y equals 2x minus 6 into this first equation, and I get that 2x minus 6 is equal to x squared minus 7x plus 12. I want to give a shout out, by the way, to Stan, because I got to give Stan, he's a math teacher, really good, phenomenal math teacher. I got to give Stan a call after this test. So if he happens to be watching this video, shout out to you. We're going to be running a really cool professional development in like May and June for Math for America. So I'm really excited about that. 2x minus 6 equals x squared minus 7x plus 12. So subtract 2x from both sides of the equal sign. If you're comfortable with it, you can actually also add 6 at the same time. But if you're not comfortable with taking 2 non-intersecting steps at the same time, just subtract the 2x first and then add 6 and do it in 2 steps. And you get 0 equals x squared minus 9x plus 18. I've already done a problem by the quadratic formula, so I'm going to do this one by factoring. Okay, so I got blank plus blank equals b, negative 9, that's the value of b. I see that the coefficient of x squared is 1, so I could do c. So blank times blank equals 18, that's the value of c. And I need 2 numbers that add up to b and multiply to c. Okay, so I'm going to do the factor rainbow. You could look for numbers that add up to negative 9 and see if they multiply to positive 18, but there's an infinite number of numbers, integers that add up to negative 9, but there's only a finite number of integer pairs that multiply to positive 18. So if 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18, 4 is not a factor of 18, 5 is not a factor of 18, 6 is already on the list, so I've got all my factor pairs that multiply to 18. If they're both negative, negative 3 and negative 6 add up to negative 9, and negative 3 times negative 6 multiply to positive 18. So negative 3 plus negative 6 is negative 9. Negative 3 times negative 6, that's these values right over here, equal 18. And that allows me to immediately factor this. 0 equals x minus 3, x minus 6. And so now I'm going to use the zero product property to get x minus 3 equals 0, plus 3 plus 3. I get that x is equal to 3. And here x minus 6 equals 0, plus 3 plus 3. And x is equal to 3. Whoa, hey. I was thinking, this is an error that a lot of other students make. As a tutor, I'll explain what just happened, because I used to make this error a lot, and of course I still make it. And a lot of students make it. When they're looking at one thing, if they immediately go to write one thing while they look at a different thing, the thing that they looked at replaces the thing that they were about to write without them even feeling that that error was made. So plus 6 and I got x equals 6. And that is a really common error. And this is actually 3 out of 4 points because I have to get x and y. So if x is equal to 3, let's see, y is equal to 2 times 3 minus 6, which is equal to 6 minus 6, which equals 0. So I got my point is actually 3 comma 0. I got one solution. And my other point is if x is equal to 6, I got y is equal to 2 times 6 minus 6. So y equals 12 minus 6, which is equal to 6. Y equals 6. And so my other point is 6 comma 6. And I got full marks on number 34. And so far, a perfect grade. Going into part 4, I already have over a 90 on this Regents, which is so good. Again, there are no diagrams here, as far as I remember. No, there is a diagram that you have to draw, but no diagram that they drew. They did draw a graph paper, so yeah, that is a diagram technically, which has to be drawn to scale. Diagrams are almost definitely. And by the way, we talked for every single other ones how to get your points. How to get your points. Get your points. Graph, and find intersection points. Find the intersection points. And so if you graph and find the intersection points and you just state the intersection points, you get a point. Okay, so number 35. Anna plans to spend $30 on balloons and party hats for her daughter's birthday party. Including tax, balloons cost $2 and each party hat costs $1.50. The number of party hats Anna needs is twice as many as the number of balloons. If X represents the number of balloons and Y represents the number of party hats, write a system of equations that can be used to represent this system. Now, I am going to write the system of equations, and I normally don't even read the rest, but I want to talk about how to get your points. Graph your system, great, and then state the coordinates of the point of intersection. One way to get your points, one of these says that the X represents the number of balloons, Y represents the number of party hats, and she says that the number of party hats that graph Anna needs is twice as many as the number of balloons. You could probably graph that as an equation. You might recognize that that's Y is equal to 2X. But this one, there's another way to get another point. So 2 points on a part 4. Look at that. If you just ignored the part 4, you wouldn't get any points. But now I'm teaching you how to get 2 points. So one way you could get it is if the number of party hats is twice the number of balloons, well, you could say number of party hats and number is twice the number of balloons. If you say 1 party hat, 1 balloon plus 2 party hats costs. So the number of party hats is twice the number of balloons, and 2 party hats is $3. 1 balloon costs 5. And how much does she spend? So 10 balloons. No, 5 times 6 is 30. So times 6. So 5 balloons. No. Yep. Nope. Yeah. 6 balloons. 6 balloons. And 12 party hats. Cost 30. And believe it or not, I said that's 2 points. As insane as this is more than 2 points because the intersection of the 2 graphs ends up being this point, and that's actually the whole point of this. So you actually have stated the point of intersection, and it's set to explain what each coordinate means in terms of the context of the problem, and this is the explanation. This might actually be 4 out of 6 points. And if it's not 4 out of 6 points, depending on the grader and the grading committee, they might debate it. It might be 3 out of 6 points. But maybe I might have to argue with some teachers to decide. if this getting your points actually adds up to 4, because 1 point here for that equation, stating the intersection points, which is 6 balloons, 12 party hats. I've stated the coordinates and stating what it means. 2 points. I think that's 4 points out of 6. But let's actually know how to do the problem. And we're going to end the problem. We're going to drop the mic and we're going to say bye. And we're going to be excited that we get a perfect grade on this test. So what do I do in these kinds of situations? As I said, I write a verbal equation first. But I do state my variables. So they gave me that x is the number of balloons. So, but if they didn't state what the variables are, I have to create the variables. Let x equal the number of balloons. And y equal the number of party hats. And then I write a word equation. Said that the number of party hats she needs is twice as the number of balloons. So a word equation is the number of party hats is equal to 2 times the number of balloons. And this is why the y equals 2x might be a quick, obvious thing. So the number of party hats is y is equal to 2 times the number of balloons. So that's a point. Okay. Now, if this wasn't obvious to you, like it might have just sounded like, oh, I just should know immediately that y equals 2x. No, actually, if you just do the work that I just did, that's when it becomes more obvious that y has to be equal to 2x. But now the second part of it is where students struggle. The rest of this is a cost statement. So she plans to spend $30 on balloons, and the second equation that you can write is the total cost. So the cost of party hats plus the cost of balloons is equal to the total cost. And so the cost of the party hats. So this is where I go from the argument from before. One party hat costs $1.50. I don't care that the 2 party hats cost $3. I really don't. Ready? One party hat costs $1.50. 2 party hats cost 2 times $1.50. 3 party hats cost 3 times $1.50. 4 party hats cost 4 times $1.50. I care about how I get the cost. 5 times the number of party hats is 5 times $1.50. So Y party hats cost y times $1.50. So y times 150 plus the cost of balloons. One balloon costs $2. 2 balloons cost 2 times $2. 3 balloons cost 3 times $3. 4 balloons cost 4 times $2. So X balloons cost X times $2. X times $2 is the cost of balloons. It's equal to the total cost. The total cost is 30. So that's a valid equation. If you like writing it in a different way, fine, but that's a valid equation. If you prefer to write the number in front, you could 1.50 y plus 2x is equal to 30. Either one of these answers is perfectly valid. I rearranged it just because I have a feeling that I'm going to rearrange it in a second. The second piece, graph your system of equations on the set of axes below. This is where your ruler and your straight edge really matters. Let me see if I can actually draw it with perfectly straight lines here. Yes, I could hold it down. I could press straight lines by pressing shift. You don't have software to draw straight lines. Are you required to draw a perfectly straight line? Actually, yes, you have a straight edge. You know that 0 balloons and 0 party hats goes here. Since y is equal to 2x, you also know that, let's see, 20 party hats corresponds to 10 balloons. 20 party hats and 10 balloons. All you have to do is draw a straight line from here to here. Okay. This one, you're allowed to go beyond. So I'm going to draw the arrow. Why are you allowed to go beyond? Because theoretically, there's no limit to the number of balloons and the number of party hats that you could buy. Okay, so that one I drew it past the 10 comma 20 with an arrow. This one we have to be careful with. So, and do we have to label these, by the way? Yes, we do. So y is equal to 2x. That's that one. Okay, now the second one, the 1.5 y plus 2x is 30. This one, you can graph it by getting y equals mx plus b, which is a perfectly valid method of doing it. We've already, your teachers have already covered that 1,000 times. And if you don't get it at this point, I don't think the best way for me to show you that is by covering that. I think maybe the best way to show you this second piece is by now plugging in test values and drawing points. If y is equal to 0 for the second equation, so if 1.5y plus 2x is equal to 30. If y is equal to 0, 2x is equal to 30. So we got x is equal to 15. Draw a dot there. And if x is equal to 0, we got 1.5y is equal to 30. And divide by 1.5, we get that y is equal to 20. And that we draw a dot there. Now this one we got to be careful in the sense that, can we draw an arrow? There actually is a theoretical limit to how many balloons and party hats we can buy. The limit is we can't buy less than 0. So these don't get arrows. The blue line that I just drew does not get arrows. But at this point now, I've gotten 4 points out of 6 in my answers. Now, this one says state the coordinates of the point of intersection of your lines. I can draw it on the graph. There's my point. It's 6 for x and 12 for y. If I just state 6 comma 12, there's no algebraically solving for it. It's just stating the graphical point of intersection. But you could actually also algebraically get it, which is why I think that this is valid. But now we're about to get really excited and celebrate a perfect grade, 100 on this test, and a perfect part 4. And we're going to do this part 4. We're going to drop the mic, and we're going to end this test and this video. So the next one, explain what each coordinate means of the intersection point in the context of the problem. So 612 means, write it green because green is the color of money. 612 means that she will buy 6 balloons and 12 party hats, so that, and the number, and you could do the simple number, and that's okay. They don't expect you to write perfect English, of party hats is twice the number of balloons. And we're writing the last few symbols. She spends exactly 3, 0. Put a period at the end of the sentence. We got 100 on this test. Pick up the mic, drop the mic. We're done. Congratulations.